Hey, welcome everyone. I'm so happy to be hosting JDConf European, Middle East and African Time Zone Edition. I'm Sandra Ahlgrimm. You can find and maybe you should follow me on Twitter and LinkedIn. I'm yeah, congratulations for making it to this stream. Before we start, we're gonna go through the code of conduct. So we have to do a little bit of working here. So just very easy. Here's the Microsoft Reactor code of conduct. In literally, it just says be nice. So please feel free to use the chat for like questions, comments, greetings. Don't use it for like spam, abuse, anything like that. So we will moderate that. And then next thing will be the agenda for today. So here we have our presenters. We're gonna start with Lize. She's already there. Lisa, she's already there with us. I can't wait to hear her session. She was with LangChain4j from the very beginning. I was at DevOps Belgium last year. I saw her session and I'm a huge fan ever since. And then we also have the newest things like for VSCode Java. I mean, it's the hot topic, right? I'm a huge fan of IntelliJ as well. And there's Eclipse, but then there's VS Code for Java, so fast and lightweight and compatible with code spaces and others. So that's so great. And then I can't wait to have my friend Oleg here on stage to give us the last and best news for Testcontainers. I mean, they had been acquired by Docker a while ago, so I would love to see if something changed already or if it's just going better and better. And then we have Rory Preddy, like my colleague here, who will present us about semantic kernel for Java. I mean, I already told you that I'm a fan about LangChain4j, but come on, semantic kernel, let's give it a try, right? Let's give it a chance and let's see what Rory will speak about this. And then Jarkarta EE, it's there. We have Reza with us from American, so I hope he's awake by that time. So thank you so much for joining us at this early hour for you. And then there's my friend Alina from GraalVM. So one of my, I actually can't decide if LangChain4j or GraalVM is my most favorite topic at the time, but yeah, she will give us like the fast and lightweight Spring Boot applications with GraalVM. And then last but not least, my dear friend Martin Lippert from Hamburg will present us about keeping Spring Boot projects up to date. So I can't wait to have him as well. And then we also have some on-demand sessions for you already. I mean, I know you don't have time during the next 4 hours because you're going to stay with us for those sessions. But just in case there's one which not your favorite or already bookmark, please hear our on-demand sessions. You can find them. Yeah. And then to not lose too much time, we also have a rewards program. It's in the chat. You can check it out. And there will also be some surveys. So you can find them in the chat as well. So, Liz, are you already here with me? So you
Hi,
can
Sandra.
start.
Yes, I'm here.
Yay! So how is it? I mean, how could you find LangChain4j? I mean, you've been there, like the main advocate for it and one of the main contributors from the start. How did you find it?
I had the luck to run into the creator. So I happened to give a presentation at work about AI and how we should integrate it in our workplace. And he came to me afterwards like, yes, that's the future. I just started making this library. And from there we took it. And he liked my presentation. So he asked me to present the first time at DevOps Belgium in October. And yeah, we took it from there.
Okay, that's just wonderful. So, and what do you have with you for today?
I will give an intro in the main building blocks from LangChain4j, and I will really show you the code so you can reproduce it at home. I will also have the links there to find it, to test it out afterwards and to modify. So you should be really set to get started after this session to make your own LLM-powered apps and AI-powered applications.
Okay, so I guess I will not steal much more of your time. So please feel free to use the chat for any questions. We have Julian Dubois with us as well, so one of the other contributors, and we can answer them then. And also we have some time after this session where Lize can answer questions as well. So thank you. The stage is yours.
Thank you. So thank you all for joining today. I will be teaching you the ins and outs of LangChain4j today. I'm Lize Raes. I'm an AI transition specialist at OpenTide. And let me start you by presenting our team. So our creator is Dmitry Lyubarsky, and he's also been the relentless lead developer of the framework. He puts in so much time making this awesome, adding new features, adding new integrations. And he's helped by a great team of almost 80 contributors by now. Some of them have also spent really a lot of time making this library better and bringing it up to the thing that it is today. So a huge thank you to all our contributors in the first place. All right, so just to be on the same page in terms of terminology, we are going to talk mainly about large language models today, even if LangChain4j also support image models. But back to large language models, we have standard language models, which are completion models. If you would send in I like, they will probably answer with chocolate, because that's something what most people like. Then we have the version of language models that are called chat models. They are trained to chat with you. So if you send in I like, they will say probably, oh, what do you like? Can I help you with something? And then we have embedding models down on this page. They are a bit different. You send in text, and what you get out is a vector, a numerical vector that encodes the meaning. So this can be very useful to find pieces of text that are similar, or to categorize things, because they will have meaning vectors that are very close to each other. And those vectors typically we can store in an embedding store or a vector store that's optimized for finding really close vectors and then popping up the fragments of text that came with this vector. Also important to know is what you send into a model is called a prompt. And so prompt engineering is basically making your prompt better so that the result that comes out is more what you like. And then we have a context window, which is how much you can send in one round. And that's depending on the model you're using and the model provider. It's anything from 200 characters until multiple pages. But it's always limited. You can't just send endless things in large language models. And you will also be paying usually for the amount you send in and for the amount you get out. Okay, let's have a look what it looks like to connect to large language model in LangChain4j. So we have a Hello World program here, and it's basically a two-liner. You create a chat language model, which is an object in LangChain4j. In this case, an OpenAI chat model. We're going to use OpenAI GPT 3.5 for the demo because that's just easier. And we have to set our key there. We even have a demo key for you to try some stuff out at home. Then you don't even have to bother making a key with OpenAI. Otherwise, you put your own key in here. So we're using this demo key. Then we have our model. And then we have the method generate. And what we say is, say hello, JDConf. So let's run this and see what the model will answer, or GPT 3.5. So there's a lot of parameters here that are set behind the scene. You can also change them yourself. So I'm in this tutorial folder here. I don't have the time today to go through everything, but as you can see, the second one is model parameters, where you learn how to set things like temperature. Okay, what did it say? It said, hello, JDConf, how are you today? So we are talking to a chat model. It wanted to chat with us. So that was how easy it is in LangChain4j to connect to a model. We have plenty of other model integrations. I'll show you in a minute where you can find them. So let's go through the basic components of LangChain4j, because we're not only going to just send text in an LLM and get the output. There's much more we want to do, and that's why we have these building blocks here. So language models, we just saw. We also support image models. What else are we going to look into today? We're going to add a memory, so we can actually chat and remember what we said before. There's tools, so we can tell the model that it can use certain tools that we programmed. We will show that afterwards. We have output parsers, so LangChain4j will take care of parsing the output to the type you want to get out, so you don't have to be parsing strings all the time. Here on the right, there's a RAG, Retrieval Augmented Generation, which is a hard word for chat with your documents, basically. And so we have some parts that are involved in there, which we will also see today. And then on higher level, we have chains, which are similar to these original LangChain chains, and AI services, which are typical for LangChain4j, and they are really awesome. I will show you in a minute. So I have some logos of integrations. We have OpenAI, Azure, Google, Hugging Face, or Llama. Let me show you where you can find them if you want to use more of them. So you can find all this information on our GitHub repo, langchain4j/langchain4j. Feel free to star it if you like it. And then when you go under all these documents, you have an intro, which is worth reading. And then here you will find code examples with Quarkus, with Spring Boot. The link to the documentation is here. Also to these tutorials I will be showing today. And if you scroll a bit further, you will also find here the supported LLM integrations list. So there's really a lot we're already supporting. Among there, for example, there's commercial model providers like OpenAI, but also Hugging Face, for example, which is an ecosystem where you can fine-tune your own models. You have access to almost every open source model out there. They have training data sets, and then you can actually run it there and easily integrate in Langchain4j as well. And Ollama, for example, lets you easily talk to a model you're running locally. If you have enough GPU and compute power on your computer, you can do that, and you're not even going to the internet when talking to a large language model. As you can see, we have sync completion, which is just normal answering. We have streaming completion, which will give you the answer token by token, which can be nice. Then you can just already read on while it's outputting. Supported for a lot of models. Then these embeddings to calculate these semantic vectors, also supported for a lot. And then some have image generations. And function calling are these tools, so also supported by some models. All right. Good. Let's start building up some more complex applications. So Chat API is a way to add memory to our model because our model itself is stateless. And it looks like this. We can send along to the model a system message, which is an instruction, like a general instruction that always applies. For example, you're explaining something to a 5-year-old, and it would apply for the whole discussion. And then in the memory, we want to keep all the messages that have been sent by us, in this case, the 5-year-old, and everything the model has answered, so that at the moment we ask our question number 3, we get an informed answer that knows about everything that has been said before. And so we don't only send this last user message to the model, because otherwise I wouldn't remember. No, we send this whole package into the model. And Langchain4j helps you manage this memory. So let's have a look in the code. I'm going to give a special example of memory where we actually fake a memory. It's called few-shot. We fake things that the model has answered before, and it will do its best to keep answering in a similar style. So this list of chat messages is Langchain4j's version of a memory. I call it few-shot history here. And I've added a couple of things in there. I've made these with ChatGPT, by the way. So I have a positive user message here, something we send in. I love the new update. The interface is very user-friendly. New features are amazing. And then we pretend that the model has answered with action, forward the input to positive feedback storage, and a reply, thank you very much, and something very kind. I've also added a negative example where something crashes, and then we say that the model answered action, open a new ticket with the ticket label, and then a reply, we are so sorry to hear about the issues. I've added just 2 more examples, another positive one, another negative one. And then I sent my real question in. So this would be your user's real question. How can your app be so slow? Please do something about it. And then we make this whole history, we send it into the LLM, and we will generate the answer with our few-shot history with 4 fake examples and 1 thing we really asked. And as you can see, this is a streaming response handler. So we will get the output token by token. Now it goes so fast that you hardly see it goes token by token, but let me show you what now happens. So with our examples and our question, there starts super fast. All right, so it says action, open a new ticket, app performance issue, and then the reply. So it's a super nice way to steer a model to do exactly what you want without having to describe it all. So that was an example of adding a memory. We'll see some more later on. All right, now we come to the very interesting part, AI services. So they return Java objects, which is amazing, but they do so much more. They are really the workhorse of the Langchain4j library, and they're super flexible. Let me show you. So here are some AI service examples, and they can get really, really complex. So we made a model to start with, just like before. And then the way you declare an AI service is as an interface. So we make here an assistant interface. We will have an assistant AI service, and it has one method in their chat, which takes a string as input and gets a string as output. That's it. So the next step is we want to actually create an implementation of this assistant by using AI services.create with this assistant class and the model we made before. And at that point, we have our assistant, and we can use the methods that we declared in there, like chat. And that's all we had to do. Like, there's not much coding involved anymore, and it's very flexible. So for example, I just took a part of a text form in French because I happen to have to fill texts out in French. And it would be really nice if I have some proper translating assistant there. And I just asked it to translate this using this chat method. And if we would run this, then we should get a translation into English of our text form. So capital gains, yeah, looks very good. Okay, that was the basic functioning of an AI services, but it gets much cooler. You can add variables and messages around it. So here we define another AI service that's a bit longer, text utils. Again, it's just an interface. We have a method translate, a method summarize, and a method extract date time from. And then we're going to add more information around this. So these are LangChain4j annotations, like the system message telling the model what to do. You're a professional translator into language, and that's a variable we've defined here. It's one of our input arguments. And then the user message is translate the following text, and then we plug in this text. So that's what it should do, and we don't have to code any more than that. We have the summarize one, which has summarize every message from the user into n bullet points, and n is an int as an argument, and then the text will be the user message. And the very interesting thing is here we get a list of strings back. So LangChain4j will know, oh, we expect a list of strings, so I will parse the output into a list of strings, and it's not something you have to do anymore. And then where it gets really cool, who else struggles here with date time and local date time all the time in Java? I just cry every time I have to do this. So I love this method, which will extract the date and time from any text. So the user message says to do exactly that. And it gives you back a local date time object. So let's try this out. We're going to create this whole text utils interface with their 3 methods on there via AI services create. And then we can use these utils. So we're going to translate hello, how are you into Italian. We're going to summarize this little text about artificial intelligence with our summarizer in 3 bullet points. And then we will extract the local data time from this little text here. The tranquility pervaded the evening of 1968, just 15 minutes shy of midnight, following the celebrations of Independence Day. And we hope the model is smart enough to deduct from that what the local date time was. So let me run this. So there's always a little latency because we have to call the model. This is going to get faster and faster in the future, I have no doubt. So ciao, come stai is indeed the Italian for hello, how are you? Here is the 3 items list summary of our text about AI. And here is our local date time. So it's at 15 minutes shy of midnight. So that's very nice, and that's correct. And I didn't have to break my head over parsing dates. Amazing. Okay. Then one last thing I want to show you with these AI services, you can also have them return plain old Java objects that you define yourself. So as an example, we are going to define a recipe object. It's just a normal Java object with a title. So the fields are a title, a description, a list of strings that are the steps, and an int for preparation time in minutes. And we're going to add descriptions. So these come from with the LangChain4j framework. If we don't want just any title, but we want something specific, we can put it here. A short title in 3 words maximum, and then short description, 2 sentences maximum, etc. So we have an annotated object and a toString method because we will want to print it afterwards. And then we create an chef AI service. So again, we just define our interface, and it has a method create a recipe from a variable number of strings, the ingredients, and it was going to return our defined Java object. And LangChain4j will take care of forcing the model to answer in this format and then to parse it to a real object behind the scene. So we create our chef and we call this a recipe. We want a recipe from cucumber, tomato, feta, onion, olives, and lemon. It's really funny because at the moment I'm in Greece, so I've been eating this every day. I think I know what it's going to suggest. Let us try this. So Greek salad boil is indeed a maximum 3-word title. We have a description. So yeah, it's going to be Greek salad. And then we have our steps and we have our preparation times. And really got back the Java object that we asked for. Good, that were the AI services. Now we're going to take it to another level. The nice thing is if we can hand our AI services tools to make them actually do things. For example, we can specify that they can calculate something and they can call our Java code, and they know that the tool is there and they are smart enough to decide when they should actually use it and which input arguments to give. And then it will use the answer of our Java methods to give a proper answer to us afterwards. Why is it taking it to another level? Because you can, of course, do more than just easy Java tools. You can access your database, change bookings, have it send emails, have it browse the web, have it do things on the web with your credit card. So it can get really interesting, but also really dangerous. So I think the future of AI-powered apps is with these tools, but you need to put really safeguards in place to make sure that these LLMs are not doing things you didn't intend them to do, because people can also manipulate them. And if they know they have access to your credit card or your database, they might obtain access. So I have another video in the on-demand series about data privacy and security when using LLMs in enterprise settings. And I'm working on a bigger video series that's really worth watching if you plan to really use this in production and use these tools a lot. Okay, let's have a look at an example with tools. We made a really easy basic one. So our tools, we all define them in one class, in this case, a calculator. We have a string length method that will return the length of a string. And we have this LangChain4j annotation saying calculates the length of a string. So our model will know. Our model will also know what input argument is expected. We have a calculate the sum of two numbers tool. We'll just add a and b, and a tool to calculate the square root of any number. So that was just a class defining some methods or tools. And then we make this assistant AI service again with this simple chat method. And then we're going to build our AI service assistant. And this time we're going to add our tools here from a new calculator class object. And then the model will know it has access to all these tools we defined before. And we have also another example of a chat memory here that's really conveniently preset and with 10 messages maximum. So it throws away any messages older than 10. Right, what we're going to ask to our model is, what's the square root of the sum of the numbers of letters in the words hello and world? And as you can see, we've added a print to console whenever one of the methods is called to observe what's actually happening. Let's run this and let's see if our model will think it necessary to call these tools. So now we sent the whole question to GPT 3.5. And we also say we have these tools. And as we can see, it called it twice, once for every string we send in. And then it found 5 characters for both. So it's going to use the add method, which is interesting because I'm sure it could do it also without calling our tool. And then it called the square root method. And then So this is not part of the answer. This is what we printed to the console here. The answer is the square root of the sum of the numbers of letters in the words hello and world is approximately 3.16 and so on, which is correct, and it could use our tools. Really nice. Okay, one last thing I want to show you today is this RAG, Retrieval Augmented Generation, to chat with your documents, because models know only what they have been trained on. And on top of that, they sometimes just invent things that are not true. That's called hallucinating, and they do so very convincingly. So a way to mitigate that and to make sure it also knows about the documents you wanted to know about, like, for example, your private company documents, you can actually feed it parts of your documentation, and it works as follows. Instead of just sending the user question to our language model, we're going to also add the relevant segments. And how do we find the relevant segments? So first, in another loop, we give it access to our documents. We say where they are. We chunk our documents into pieces, because entire documents in here, they would take up too much of our context window. If it already fits, then it's very costly to give more information than needed. So that's why we will first split the documents in small pieces. We will, for every piece, calculate this meaning vector and store that in this embedding store. And at the moment the user asks a question, we're going to also calculate the meaning vector of the question. And we're going to find the vectors in our embedding store that are closest. And those are the parts of documents we're going to pop up. And then we put them here. We say, hey, this is the question you have to answer at the user question. And here are segments that may be relevant in answering. And that's the whole thing we send to the language model, and it will give us an informed answer. So in LangChain4j, it's a part of ongoing development, this RAG. So the way I explained it to you now was naive RAG or easy RAG. So let's have a look at easy RAG. It's new since 2 days, since the release 0.29, since 2 days. So first we're going to load all our documents that are important to give to the model. Then we will build again such an assistant AI service. And this time we're also going to add a content retriever that it has access to. And we're going to create a content retriever with these documents that we've loaded before. And then every time we ask a question to our chat model, it will go retrieve the parts of the documents that are relevant. If you look in this create content retriever, you see that we also choose an embedding store. We have a convenient in-memory one. In LangChain4j for prototyping, it's really nice. But then there's a lot of other embedding stores that we support also really easily. And then we create this content retriever. Let's run this. So what this one does is it has access to terms of use of a company called Miles of Smiles, a car rental service. Once it built this, there's a lot of logging here, so you can see a bit what's happening. So my turn. Can I cancel my booking 3 days in advance? And so now what's going to happen? It's sending this question to the retriever. It's creating a semantic vector. It finds relevant documents, and it says it found 3 parts that are related. We're not seeing them here, but the model gets them. And then it will answer based on my question and the parts of our terms of use that it found that, based on the Miles of Smiles services terms of use, you can cancel your booking up to 7 days prior to the start. So if it's less than 3 days, cancellations are not permitted. So we cannot cancel our booking. So again, this is a really powerful pattern to use. We have naive RAG, where you see a bit more in detail how everything is built up, and you can set some extra parameters. I invite you to have a look into it. And then also really interesting, naive RAG, where you just get the relevant segments like we saw it, is good for some applications, but for some types of documents, it's really not good enough. It will not find the important segments, or it will find other things that are really not relevant, and then it confuses the model. So we have also advanced RAG, where there are things like query compression. Instead of just embedding your question, it we use an LLM to rewrite it in something that will tell more about the meaning, so you already find more relevant pieces. There's re-ranking, for example, that when it has the pieces, we'll put them in a different order or drop something that's not relevant. So yeah, it's interesting to look into if you're gonna go deep into RAG. Right, one last demo. If we put this all together with the memory, with the tools, and with the RAG, with the documents, and we even
Hey,
add
Lize, I think we ran out of time.
All right, then I will make it very short. Right, I have a chatbot here that does it all together. And if I say, hi, I want to cancel my booking, it will know it has tools to find this booking, tools to cancel this booking. It will know our terms of use, and then it will ask me for booking name, booking number, surname, etc. And then I can really go look for my booking, cancel it, because this agent knows everything together. So to wrap it up, here are the useful links to our repository, plain repository and examples. And then I hope you enjoyed this talk, and I'm happy to hear what you'll be using it for, what you want to build. I hope you're inspired to start building something, and we're looking forward to your contributions as well. Thank you very much.
Lize. I can tell everyone that LangChain4j is also great tool to contribute. I'm here with you. I also just added some examples to the example repository, and it went through smoothly. It's just great to use it, and I love the fact that you can switch between models. So that's cool. So one main questions we had in the chat was, what does 1968 mean? So you had it like in your examples. Or in your VSCode IntelliJ?
I must say, I don't know. We probably generated the text with ChatGPT as an example to check if it's able to find when Independence Day was in that year. But maybe there's more to it. I can try to figure out.
Okay, so now we made everyone excited. So go and share the project. And if you like the session, also give us a thumb up for the YouTube stream. So thanks again for being with us. I'm sure we're going to see more of your sessions in the upcoming conferences, and also more about LangChain4j from various other people. So, and I also have a fun hat with me. So, great. So, and here are the next presenters already on stage. Feel free to unmute yourself so you can also speak. So I'm here with Roland, Nick, and Mohit from Red Hat, and also from Microsoft, because I want to know more news about Java on VSCode. So what do you have for us today?
We're here to talk about VSCode Java.
Yeah. Do you have a LangChain4j example with you?
I'm sorry, say again?
Do you have a LangChain4j example with you?
I'm kind of wishing that I prepared a Lang4j example just for this. I actually do have an example of deep learning for J, but just missed the mark by a little bit.
Okay, so with that, Lize, do you want to say anything else?
No, thank you for having us, and I'm looking forward to the rest of the talks today.
Yeah, thank you for being with us. So, and then I would just hand it over to Roland, Nick, and Mohit. And as said again, please use the chat for any questions so we can give it to the projectors. And yeah, thank you for being with me here. And the stage is yours for Java on VSCode.
Thanks, Sandra. So I think I'll get started given we have a good amount of time. So let me go to this. So let me know if the screen is visible to you guys. I think that should be good. Okay. So the topic for the session today is mostly around Visual Studio Code Java IDE extension and how we are elevating the developer experience around it. This has been one of the highly used IDE extensions for Visual Studio Marketplace. And in the next 20 or 30 minutes, we are going to talk about what new features we have came up with, what's the future roadmap, and a very interesting demo around the latest support for Java 22 and much more features around the extension. So I'll briefly introduce the team, what we have for today right now. With me, we have Roland and Nick, and myself, Mohit. I am a senior product manager working at Red Hat, and I look around all the IDE extensions across different IDEs, including Visual Studio Code, IntelliJ, and Eclipse. I manage the entire portfolio for developer experience. Roland here is the team lead for the entire ID extensions. He's a principal software engineer, and he's the, I should say, the genius of the guru for VS Code Java. And we have Nick from Microsoft, who works very strongly with Red Hat together to make sure the entire developer experience around Java is up to date with all the features and multiple extensions we have from both Red Hat and Microsoft. Great. So what's the story behind this session, right? So as you can see, this story is very strong collaboration between Red Hat and Microsoft, where we make sure that the entire workflow with respect to the Java support, the Java experience for VS Code is taken care with the support of the community, with support of the latest version of JDK, and also supporting from the starting version of Java to the latest release. So that's where the two companies work together in a very strong fashion, and something which we are really proud of, because you can say everything is done in an open source way. The code is open on GitHub, it's available on Marketplace, and we ask for a lot of contributions from the community. And that has also made sure the extension reaches a very strong number of installs and downloads. Currently, we have approximately 34 million downloads with a number of approx 2.5 million Java users. So that's a very strong affinity for Java users who are comfortable writing their Java applications or developing the Java applications on VS Code. Now, what's the important factor why we want to level up the Java experience, right? Because something this is very critical for us in terms of developer experience. So inception when we did with this Java journey, where we wanted to make sure that developers can do the Java workflow without working with the complex ID or without installing a lot of dependencies, right? So let's say supporting popular frameworks like Quarkus, or supporting a container tooling, or integration with any cloud provider. Now, when we talk about that, the important factor here is to how to support the Java ecosystem on your local ID. And based on multiple surveys across multiple status, for example, the latest survey which was done by Stack Overflow for 2023-24 was that VS Code is the most installed and preferred ID for a developer, right? And this is where we want to target the Java experience. So writing your Java application on a VS Code instance and making sure you have the code assistance, the performance improvements, the import workflows, support for Gradle, Maven, and other dependencies are streamlined. And that's where something both Red Hat and Microsoft are making sure we define these workflows in a much better way. And it's not just one Java extension. It's if you can see on the marketplace, there's extension pack for Java, which works with debugger for Java, test runner for Java, Maven, and other dependencies which you want to work with your Java workflow. So on a very high level, these are the three different workflows which you want to target. And this is something which you will also see in the next few minutes when Roland will be presenting you with a very streamlined demo. So let's go deep and see and understand what exact features are we targeting with our developer experience with Visual Studio Code Java extension. The first is definitely it's an open source project, so we encourage a lot of community involvement and a lot of involvement from different Java developers. Make sure their experience, their performance issues, and other stuff are taken care of. And with today's demo, we are also targeting some of the beta feature releases with Java 22 and Java 21 support. And we have seen multiple customers when we talk about normal developers or enterprise customer developers, they are very much comfortable in writing the Java application starting from Java 8 and going forward, right? So it's something which we support from the start to the end, and that will keep on improving down the line as we do more releases. So let's go ahead and see. This is the entire stack what we have currently with the VS Code Java extension. You can see this has a support for JDT language server. Currently, the install numbers as of today morning was around 33 million. So this is updated, and we keep on seeing a lot of installs happening. With respect to the support, as I mentioned, right, we start from 1.5 to Java 21 plus, right? Given in March, Java 22 was out, and we are actively involved in making sure the support is available to the developers and to the enterprise customers. We have code completion support. We have a very strong extension pack for Java where you can do debugging, Maven dependencies, and test runners. A very strong code length support where you can reference and implement all those import functionalities. And we have also seen some of the feedback coming from the community where they have observed that coming with every release of the ID extension, which we do every month, the code refactoring or the source actions are very much improved, so which basically improves the performance of the entire workflow. And the most important stuff is we allow a lot of enhanced support for Quarkers, and also making sure those standalone Java files are pretty much supported for a cloud native development or deploying on any cloud provider, let's say OpenShift on Azure or an Azure cluster. So that works seamlessly. As I mentioned, this is the latest stat, what we have with respect to the Java ID extension, approximately 33 million installs. That's the #1 extension when we talk about VS Code experience for Java developers. And we have a very strong active Java users group, which is approximately 2.5 million users. And that's something which we think is going to also enhance the entire workflow of the extension. Let's come to the important part of the session, which is why we are doing this. What's the enhancement a user will get when they work with VS Code Java extension? So this is something which we call as inner loop, which starts with you as a normal developer are having your application running locally on an IDE, and you want to perform the inner loop process starting from writing your code on a favorite IDE, running your code based on your dependencies, deploying your code, and once that is taken care of, and debugging your code. And that cycle keeps on reverting till the time you are very much satisfied with the entire process, that your code is up to date and ready to be sent to the outer loop section of the things, which means deploying to a production cluster. Let's say deploying to OpenShift or you're deploying to Azure. This inner loop cycle will allow you to make sure that entire code base is up and running so that it can be moved to the production cycle. And this is where the extension comes very handy, because when you're working with VS Code and you have a Java application open, the VS Code Java extension allows you to perform multiple workflows like code completion, enhancement, import selections, and other stuff. Those type of things are taken care of, and that way your inner loop cycle with the extension is improved. And by this, I would be very happy to hand over to Roland, because this is something which we are going to talk about, Java demo, where he will be talking about how the Gradle support is improved, what we are doing with the latest language server features, how the build and other ecosystems are taken care of with respect to JVM options, performance improvements, and other stuff. This will be a very interactive session. So, and we also have a live Q&A happening. So feel free to have your questions ready, and folks from Red Hat and Microsoft will be ready to answer them. So by this, I hand over the screen to Roland, and he will be taking you forward with the exciting demo. Roland, over to you.
Sure, thanks so much. So yeah, this will be for sure interactive in that if you have any questions, feel free to ask them in the comment section. I'll start right away. So I'll try and be as fast as I can, just because it's not possible to get through all the features or even to explain all of them. I'll try my best to stick to relatively new features and kind of just gloss over some more established ones. So for this, I'll just quickly switch over to the extension tab. And I just want to show you what I'm going to be using for this demonstration. So I've just got language support for Java. This is a pre-release version. It does contain Java 22 support. And this is something we're hoping to be releasing basically next week. Early next week is the plan. But for now, it's a pre-release. You can access it from the marketplace. I've got the debugger for Java extension as well. Hopefully, I can show you some debugging of Java applications. And basically, don't judge me too harshly, but I do have an extension for Eclipse key maps occasionally. There are key maps from Eclipse that I like, but there's also ones from VS Code that I adore. So I kind of have a mishmash. And just to mention what Mohit was talking about, so we do have an extension pack for Java, which contains a lot of these goodies kind of bundled into one, including the Java extension. All of that is there. So that's roughly what we're going to be covering in this demo. So with that out of the way, I'd just like to click on Open Folder, and I'm going to be importing a project. It isn't Hello World. It's maybe a little bigger, but hopefully it's motivational for the session. So it's just from the Deep Learning for J, DL4J library. There's an examples repository. So this just contains some very basic examples of models, and essentially they're being trained and you can access them. And so I'll just open this. And immediately you can see the Java extension is activating. If you click on it, this is sort of new. You have access immediately to your Java settings. You can open logs. You can clean the workspace cache. In some instances, that can be really useful. And you can see the extensions already loaded the project. One thing I would like to show is if you click here, you'll see the problems view. You have all of your errors, warnings. Well, we don't have any errors at this point, but you have warnings and to-do items. So they're all imported from every file. You don't need to configure that. You don't need to click on a particular file. Everything is just here. And if I do open a file, from the bottom right here, you can see the Java compiler that has been selected for this project is shown, as well as the build configuration file. So we support Maven projects, we support Gradle projects, and we also support a kind of project which is just, you have a folder, you dump some source files in, and you can kind of develop that way. We call it unmanaged project. So you have a lot of options, is what I'm saying. But, and the other thing I think makes sense to start now is just, let's start with navigating the code base. So for this session, I'll be showing navigation, editing, and maybe at the end, a little bit of debugging. So one of the first things I did is I opened a file, which you can easily do if you click on Go and then go to File. It's not particularly groundbreaking. I think you can do that. But because we also index the entire project, we can access files using that. So using the go to workspace symbols prompt. And that's actually available from go to symbol and workspace. And so because the Moon classifier file is contributing a type declaration, when we look for it, we can find it and immediately jump to it. If for some reason, let's say, you know there's a method called something, let's say train data, but you can't remember exactly which file it's located in, then another thing you can do is, okay, wasn't expecting this, but basically what can happen is you'll search your workspace symbols and you should be able to find the method. And if that doesn't work, we'll just click on the file. So let's do that. But basically this is a feature that usually works and you can, oh, there we go. And yeah, it works. All right, awesome. So it could just be because I'm sharing my screen, it's taking a little longer, but there's train data. And when I jump to it, I immediately go to the method declaration right there. So just another really quick way of searching things, and it makes it really straightforward to jump from various places. Another way you can navigate the code base, obviously you have your standard go to definition. So you can just control click and you jump immediately, obviously, to the type declaration. You're not jumping to line 1 of the comments. So it just makes it really easy to navigate. Another really simple way to do it is through type hierarchy. So for example, let's say we have this data set iterator and we have we have our data. Maybe we have our training data, or in this case, we have our test data, and we'd like to see what kind of libraries there are that can parse it. So we can just right click the data set iterator and go to show type hierarchy. And that should load the type hierarchy for all classes that are basically implementing the dataset iterator. So just one word on the index. It was a little kind of rusty there, but I will say one of the things that we have improved a lot on is just index searching. And the reason we were able to do that is through shared indexing. So if you use the same libraries over and over again in your code in different projects, we can look at that and then determine that that particular index should be reused. And it just makes it a little faster to search things. So that's basically the story as far as navigation goes. You'd have pretty much everything you'd expect. You even have, you can go to declaration, pretty much all of that. So with that out of the way, let me just jump into editing. So actually, one of the things I really like about VSCode that I think is really nice is snippets. So I think snippets are really cool. And just the ability to build something up from scratch just by hitting a particular item, even with the Java language, making it easier and easier to kind of build up code that's less verbose over time as new language features are released. It's still nice if you're stuck on an older Java version, just to be able to take advantage of snippets. So one thing we were trying to look at is making our snippets a little more intelligent, making them make a little more sense where they're accessible. So immediately, if I just try out the class snippet, you can instantly see it's got a license header, correct package name, correct type declaration, all of that is there. And if I activate it once again, and the file license header is configurable, if I activate it again, you'll see it looks a little different. And that's simply because it understands some basic context about where it's being triggered. So I can kind of change this around and play with it. So let me just create a main method here. I can do a constructor as well. And actually, one thing that I'd like to do is let me show you some Java 22 features. So I think that makes sense. And also that, let me go back to snippets. You can see I can't access the method snippet here, but I can within the type declaration. Oops, there we go. So we're going to switch to another version of Java pretty soon. I'm just going to write some stuff that I'd probably need Java 22 support for. And let me just copy a piece of code. So let's say you're writing, like you have a particular file, you have a text block, and you just have some code in there that's represented by some other language. Like let's say it's HTML or it's XML or it's JSON or something like that. So I'm just going to be creating that text block here. All right, I'll paste the code. Obviously, this doesn't work because Java 15. So we'll go to the bottom right here. We'll switch to the build configuration. We'll set it to 22. There are easier ways to navigate Maven build configurations, but for this demo, I'm just going to do it the basic way, which is in the POM file. And here, I'm just going to enable preview features. So I think that's just compiler args. And then enable preview. I'll hit save, and the project should automatically detect that I've modified a build file, so a build needs to happen. And so all I'll do is go back here, and you can see everything's loaded. And even the Java 22 preview feature of statements before super is working just fine. But what I wanted to show you is, obviously, we have really nice syntax highlighting. We can actually give a hint here to the text block, just in this format, to let it know that it's a YAML syntax. And once we do that, we get some nice syntax highlighting. We support it for XML, for YAML, for JSON, and a few others. As long as VSCode supports the syntax of that language, we can really easily support it under VSCode Java for text blocks. So just basic things like that that make it really easy to kind of navigate the code base. There's also really nice features like beforehand, certain code actions, maybe you'd have to rename the file or rename it back to the correct type declaration. If you hit save, it just auto updates everything. And yeah, although I did change the constructor, I'd have to change the constructor. So let's just leave it like that. So I think if I've got a little bit of extra time left, I'll just quickly show you just some debugging. So I'll switch over to the Moon classifier. And for debugging, it's same story as always. We'll just set a breakpoint immediately in main. And then there's a couple ways we can debug. We can just debug Java. We can hit debug here. But let's just click debug, start up, and immediately we're on this line. So we can step over, we can step return, we can just continue. We can inspect various values. And one other thing I'd like to show you that is relatively new is beforehand in the debug console, you would have access to a lot of different types, and you could use them. So now, let's say you're accessing something that isn't within the import statements of the particular file that's on the stack trace. you can simply have it fully qualified like you saw below. So you won't get just ND4J or anything like that. You'll have it fully qualified and you can use it that way. So those are some of the basic features we've had. Some of them are relatively new. Some of them we've had for a really long time. Some things that I'm really looking forward to in the new specification for the language server, there is the ability to use snippets within text edits, within workspace edits specifically. So I'm really looking forward to that just because it opens up the world to using a lot of snippets within code actions, really has the ability to simplify a lot of UI elements we have, a lot of things like that. And overall, I think we've just been focused a lot more on performance, specifically for code completion and importing of projects. There's a lot of things we've severely simplified. But with all of that mentioned, I hope I've motivated you at least to try this VSCode Java out and a lot of the tools within the ecosystem. And with whatever time's remaining, I'm happy to hand it over to Nick, who's going to be talking about our roadmap, our shared roadmap, and some of the things we're hoping to do in the coming months.
Yeah. Thank you, Roland, for that amazing demo. Would you mind sharing the roadmap slide? Yeah.
Roland, can you hear us? Okay, it doesn't.
Yeah, I'm here.
Okay, we need to share the slide deck for Nick to take it forward, like the last 2 slides.
Have you got the slide deck? I don't actually have it up. Once I was just having the VS Code
just one
instance up. Yeah. Apologies for that.
No worries. Nick, can you see this?
Yes. Okay. Cool. Yeah. Yeah. Thank you, Roland, for showing the demo. So we just saw that what VSCode Java is currently offering. So I'm going to share a little bit. We're planning to do in the next couple months. Fundamental experience impacts the developer experience every day. So in this category, we're going to keep trying to keep up to date with the latest JDK. This is always our top priority. We will also look into providing enhanced code navigation and advanced debugging capabilities. One important investment in this category is that we will integrate Java-C compiler in our tools as alternative to ECJ. This will offer us better build results as well as even faster pace to support new JDKs. The next category is performance and reliability. This is our next top focus. We want to make VSCode Java more stable and reliable. In this category, we want to reduce unreliable sessions and optimize our performance. In terms of compatibility, when we released the build server for Gradle last year, we received some good feedback from the community. So we're going to keep improving the project import success rate of our Gradle projects. Mohit, would you mind moving to the next slide? Yeah, thanks. So now we've been hearing that our project management experience in our extensions is still quite not good enough. So we're going to improve our JDK configuration experience, adding better project creation import experience, as well as improving package and class creation interaction. This actually leads to the next category, user experience. We will refine some of our user experience so users have better paths to code action and refactoring options. We'll also make it easier for users to discover some of our user settings to Java language server. The last part is AI. We all hear about GitHub Copilot and Copilot Chat. In the next couple months, we're going to have much closer integration with GitHub Copilot Chat in our extensions, so we can improve our Java developer coding efficiency for our day-to-day scenarios. That is all I wanted to share today for our roadmap. Yeah, thank you for all listening, and feel free to continue leaving comments in the chat.
Thank you so much. That was so great. We do have some questions in the chat. So if I want to use the Red Hat extension, do I need to have Java installed on my machine?
So that's a really good question. For most cases, the answer is actually no. We ship a JDK within the most common platforms that people use. So if you're on a standard Linux, Mac OS, Windows, more often than not, you do not need to have Java on your system. It's usually a good idea if you have a particular Java compiler version you're targeting. Obviously, you want to have that version of Java. I believe the version we're providing by default is 17. So basically, to answer that question, no, but it's usually a good idea.
Seriously, there are no stupid questions because first of all, I thought, well, you're gonna program Java apps, so obviously you might have Java installed on your machine, but then, as you said, you might use dev containers or in container versions, so and then you don't have it on your machine. So I'm very happy that we do have the JRE shipped with it. So
Yeah.
that's great. And yeah, I think. Does the extension support debugging yet? I mean, we saw the debugging, so maybe this
Yeah.
person just
Yeah.
joined late. So
I
I
think
think
sometimes
that
it's just tricky for people to figure out maybe what's available because it's in a separate extension as opposed to just grouped into one. So maybe it's just something we need to do a better job at kind of getting the word out that, hey, if you want this feature, it's here. If you don't like how this works, settings.
I mean, Nick, don't we have the Java extension package that we
Exactly.
usually recommend, where you have the Red Hat and the debugging and tests and everything included?
Yeah.
Yeah.
So we recommend people to just always install extension pack for Java. That includes everything, including debugging, project management, Maven for Java, and everything. So yeah.
Yeah, thank you so much. The main thing here I get from this is that I can actually already use Java 22 for my next programming exercises. So that's just so cool. And thank you for being so much up to date and making my Java development like also so speeded up, especially for small projects. It's always so handy if I just open up VSCode very quickly.
Yeah.
So thank you for being with us. I
Thank you so
assume
much.
you're also
Thanks
going to
for the
be on the
time.
chat for a little while and if we have more
Sure.
questions, because we
Yes.
already
Sure.
have Oleg waiting for us.
Yeah. Thank you so much.
Hey, Oleg, are you using VS Code for Java already?
Hi, no, I'm a big fan of IntelliJ IDEA.
Don't say it.
This is my go-to IDE, and
Okay.
I've been using it for a while, like literally almost a decade, more than a decade, I think. So.
And as a Java champion, you have it for free as well, right?
Yeah, I'm using the Ultimate Edition. Actually, my employer pays for the license, but yeah, Java champions, Docker captains, and some other champions, ambassadors do get licenses provided by JetBrains.
Okay, thank you. And you're here for Testcontainers?
Yes, I work in Testcontainers, and this is the session about mastering Testcontainers.
Okay, I can't wait to get the newest things out of it. And you're also wearing a Docker shirt, or what is it?
Yes.
What do you have for that?
Docker shirt, yes. I was a part of Atomic Jar, which is a startup, and Docker recently acquired us. So now the Testcontainers team is working at Docker, and it's been a great collaboration so far. And I think it's an excellent place to be because Testcontainers always relied on Docker as a runtime. And now we have really good access to the upstream dependencies like maybe Moby as a runtime, or we can do a better integration with Docker Compose. Because we have the direct access to the team. So I think it's been a great move.
Yeah, so also the Red Hat guys are listening very carefully because I know Quarkus is also making great use of Testcontainers. So we're all in this together. So thank you so much, guys, for your presentation on VS Code for Java. And Oleg, I mean, the stage is all yours. Please go for it.
Thank you so much. Right. This is a session about mastering Testcontainers. My name is Oleg Šelajev. I work, as we mentioned, at Docker. I'm in the DevRel team. And through the years, I've talked to very many people in the community and customers about how they use Testcontainers, what are the common pain points, and in general, sort of, we communicated a lot with different teams at different levels of proficiency and value they get from the test containers libraries. And then through those conversations, we distilled the common practices and common patterns, how to, like, which are the most common pain points after you start using test containers and you like the approach, and this is what this presentation is about. So I would like to show you a little bit about the setting up the local environment experience, not just using test containers for tests, and a little bit about how to set up more complex environments, including the networks. And of course, I have a little demo of a Gen AI stack as well, which I will use to show more precise lifecycle control. So in general, why do we talk about this? Is because tests drive productivity. Tests drive productivity in a number of ways. And there were recent papers on developer productivity. What does it mean? Which distilled it into 3 particular axes, which you need to improve to get better and more productive. It is improve your feedback loops, both speed and confidence, reduce the cognitive load you need to keep in your head to perform changes in your code, and build your processes in a way that allow you to maintain the flow state where you can work on the particular tasks, making progress over longer periods of time without constant interruptions. And that's exactly where tests come in. And why is it so important? Because your developer linear loop looks like that. You find the place to change the code, you change the code, and then you need to understand whether that change was good or not. You need to test. You don't have to commit on every small iteration, but essentially you do need to get the signal whether the changes that you're introducing are good or not. So you need to test. If you don't know how to test well, if you don't have the paved road, paved path for adding new tests or verifying changes in a way that actually gives you confidence that you are on the right path, then you're going to stumble upon that, and you will never get to the point where your productivity flow goes up and to the right. So every time you're going to stumble, every time you're going to get an interruption, and this red line will be all over the place. So this is where test containers comes in, because through the history of the industry, we realized that we need more reliable and more sort of similar to production tests that you can reproduce locally. And we tried different approaches, from mocking to using locally installed tooling and setups for your applications, to abstracting away the whole environments. And then Docker came in, and you can abstract away just a part of your environment. Your application runs locally, your IDE runs locally, you're productive with that setup. You don't need to have this limited experience with tooling that is only available through the thin client of the browser or like an Electron app. You can use all the tools locally that you wish, but your components of the infrastructure that are required for your application to run are containerized and run on demand. And this flexibility, the ultimate flexibility, is when you use that programmatically, because then your application itself can define what environment it needs to run in and go forward and run very smoothly. So this is where test containers comes in, right? Test containers are open source libraries, and they give you the API to work with containers. You can define the containers, you can configure containers, and you can manage the lifecycle of containers programmatically from your code, which brings you a number of benefits. One, you're always in the code, so it will never get out of sync with your application needs themselves. Second, you are in the code, so you can easily introduce abstractions that can hide the implementation details from the end users, from the developers who would actually build applications. So it's an excellent tool for platform teams, or maybe if you are on a more like senior experience with test containers level, right? If you've done more setups like this and you know which parts you would like to abstract, you can help your fellow developers and teams to be more productive by defining your own test containers modules. And also this abstraction provides you with convenience API. So you can configure your applications work with those ephemeral lightweight instances running in containers just by writing a few lines of code. So it's all very, very good. Test containers is an established library, and we know how to do integration tests. We know how to set up the environments. So we try to take care of as many concerns for the integration tests as possible. For example, we will do automatic cleanup. We will ensure that the configuration is by default, right? We want to ensure the best practices. We want to not maybe support out of the box or easily practices which we consider inefficient, which will prevent parallelization of your running your tests, for example, and so on. So test containers takes a lot of burden of creating environments from you and hides it behind a facade of a library. And that's why it's so great. You can run anything you want in a Docker container. You can run different types of technologies, from cloud emulators or cloud technology emulators to databases, to NoSQL stores, to GenAI stack, to message brokers, to web browsers, to tooling, to Kubernetes clusters, anything. And because the technology is so generic, right, you can build your own solutions that will fit your needs. And when we asked our community how they use test containers, they said that most use more than a single type of technology at the same time, which is very, very interesting, because you can have, like, maybe you can work with a database or a particular technology in a way that would, in some other ways, right? You can provision your cloud resources, if you will, if you need just some resources. But having the setup where all those pieces work in the same way, belong to the same life cycle, this is not very easy to achieve, and test containers fits the bill there perfectly. So it achieves that by giving you the ecosystem of modules, which are predefined abstractions to run anything in Docker containers via test containers. Those are modules contributed by the community or within the partnership between Docker and a particular vendor of the technology, where test containers team brings the insight about how to do testing and integration test part and local environment setup, and the technology vendor team brings the information about how to run their particular thing the most efficiently. So Red Panda, Local Stack, and some others are official modules, and you can get the best of both worlds, and you don't even need to know how to run particular things in containers, which, in my opinion, modules are what made test containers so popular all over the world. So test containers allows you to get the environment parity between your CI and dev environment very, very easily, and allows you to use the same technologies you use in production in your CI very, very easily. The only thing you need is a Docker environment for us to run the containers in, and that is usually what is available locally on your machine with a Docker desktop or other solutions, and it's usually readily available in CI as well. So you get this environment parity, you get the ability to create those high-level integration tests, and then you can take it to the next level. So let's see how it works. Let's see how it works. I will go into my beloved IDE. We will start from this one. We'll start from this one. There is nothing test specific in my API. But what I can do, I can define the containers, and I can handle the lifecycle of my containers and use Convenience API to configure my application to use those. So here we define the Postgres container. And if we look at the POM XML, you will see that I have my my Postgres test containers module added as a dependency. You can obviously use it with Gradle. There are also implementation of test containers libraries in other languages, but this session is, of course, concentrated on the JVM world. So you get the abstraction for running the container. You can run it, you can start it, you can get the URLs, you can stop it, and so on. I can run this application. This is very easy, right? The test containers library will determine my Docker environment, will run the checks, and then will pull the image if it's necessary, and then run my container in there very, very nicely. Print the URL. This is it. Now, How do I configure this? I configure it using the just the Fluent API. I can override the any properties that I need. I can override the command for starting that Docker image. I can, well, obviously I can change the Docker image name if I need to. I can override the environment to provide some properties. I can do anything I want. I can specify the waiting strategies, which is a very important part of what makes Testcontainers modules so efficient. Because when you run the container, it's not necessary enough to wait for the container to start. We also need to make sure that the service within the container is ready. So that's where the waiting strategies are coming in. So you can wait for any condition that you want, for the ports to be open, for the health check to succeed, for the responses to certain queries on work, or for statuses for the commands to be all right if you want to run a command within the container. Usually you can also just wait for the certain log message. So when Postgres starts, it will print something in the logs like, oh, Postgres is ready to accept connections. And that's where we can determine, yeah, after that point, it is ready because it's written that in the log. So we can wait for that. You don't have to specify all that yourself, of course, because Postgres container will take care of that for you. Now, this is how you run it, and this is the simplest part, right? What you else need to do, you need to configure your application to use Testcontainer setup, right? You need to configure your tests or your application to work with that. So here's my situation. I use Spring application. I will use Spring Boot 3.1 modern. Previously, you had to do some of the things manually, but now what I can do, I can expose Testcontainers primitives, Testcontainers objects as beans. And Spring Boot is aware of Testcontainers and has a very tight integration. So if I just expose beans like this, Spring Boot will handle the life cycle for me, right? So I just define the dependency on Postgres and say it's a bean. It will be started within the Spring context. Other frameworks like Quarkus and Micronaut have similar capabilities, and they have integration with Testcontainers. So you also don't have to provide all the details, handle the life cycle yourself. But this is how you do within the Spring Boot. You also have the service connection annotation, which is extremely useful, specifically for the local development setup. When I don't want to run my application with tests, but I want it just to run my application as my application. What service connection does, it takes the Testcontainers primitive and it makes it the default choice for that particular type of technology. So if I have the service connection on the database object container, then the Spring Boot will use that as the main database. If I have my service connection on the Kafka container, which is you start exactly like this, add a library and say, give me a new Kafka container. It will configure the Bootstrap server's URL for you, and Spring Boot will prefer now that as its default Kafka endpoint. Now you can still override all that configuration. So here I'm starting local stack, which will be my model for AWS cloud, because this particular application uses we use this S3 for something as an example. And there is no service connection for local stack in this version yet. So what we can do, we use the dynamic property registry object and we inject it into our bean creation method, and we can override any dynamic configuration on the fly. So we will create our containers using local stack API, using Testcontainers API. In this case, this is local stack container, and then we just can override the access or region or endpoints in our configuration, and whatever is in the application properties or any like environment variables, the Spring Boot will prefer during the test runs, will prefer this dynamic property registry config that is available on demand. So our application will connect exactly to those things. Now, with those beans ready for my application, I can of course specify them in my tests. I can import that configuration into my tests, and then when Spring Boot will start the tests, it will find the containers, inject them into the bean contexts, and then handle the lifecycle of those. The other frameworks will do the same. If you don't have support of the framework to do so, you can very easily do that manually by just specifying in somewhere before each or before all to start the containers. You can do this with whatever test library that you use. So, but the benefits don't end there, right? What you also can do, you can just run the application, not within the tests, but within just the local application development scope. So I can run my application here from the test class pass, augment it with the container config, get those containers started in my Docker environment, and then connect my application to that. So after that, I can have my application just ready and interact with it as usual, right? So we'll need to wait for it a little bit. I'm using the Testcontainers cloud as my backend, and it provisioned me a new VM, so it will pull the images. And if you have the images in the Docker cache, it will of course use that naturally. So here I need to wait a few more seconds before it downloads the images into my remote machine. See, this is it. Starts the root container, which is the resource, reaper. But all in all, my application is running, and I can use it. I think at this point, right? No, I cannot use it at this point yet. Perfect. Oh, I have my other application running on 8080. Sorry about this. Let me see. This one is not running. This one is not running. This one is running. Right. I can run my application. This is a perfect example of how the images second time will not be pulled, but it will start and it will run very, very easily, right? So now the application will start and it will work with me. Work with me? Right, so work with me, something was created, the response is 200 plus, so it means, okay, now something was added to the database. How do I work with this, right? Well, of course, I can look at my Docker PS and see my containers there, but it is a little bit hard, and the configuration for those is fully dynamic, so it's not as convenient. I'm using Testcontainers Desktop, which is a free application, so it gives me a few things. It shows me the containers running. It allows me to pick the runtime, whether I want to run my containers locally or in the cloud, and it also gives me this abstraction of services. In general, we wanted the desktop application for Testcontainers to be packed with developer-facing tooling, and one of those things is services, which gives me the local machine local configuration to connect to some things locally. So for example, if I'm running Postgres with Testcontainers, I want this desktop application to proxy local port 5432 to the container, whichever container is running Postgres. That means that I can run my tooling locally as if my database was also local. So I'm going to use this static port here, and despite my container running on the random high value port, to avoid any conflicts in when running parallel tests or anything, I can get access to it and I can use it, and I can see my data from the queries right there. And you can do that with all the technologies, and it works on the same way. Right. If I want to configure things further, the most default option is to copy files into container and define what is the configuration for the things there. Usually that would be either your database schema or configuration for things, or some other files that you need for service in the container to run properly. You can copy files back out if you need to access logs, or if you need to access some results of running the things in containers, and you can do that programmatically as well. Now, this is the local setup with Spring Boot. It's very, very convenient to run this But you can also do more complex things. What you can do, for example, you can run, for example, more complicated setups. Here in my code, what I do, I run my Kubernetes cluster with K3s container, and it runs the actual Kubernetes cluster. I can deploy things into that cluster if I need locally. I can expose services from the Kubernetes cluster. I'm using the API to do so. I can connect networks on top of this and create complex deployments. If I, for example, want to have my database talk to my application and have my Kafka schema registry work with my Kafka setup, I can do all the complex deployments here. Right. So in this example, I have my Kubernetes. I can run it. This test does nothing but just deploys things and works. So I will freeze container shutdown here just to avoid my test to disappearing. So the container shutdown, my desktop application will stop. So we can inspect the Kubernetes cluster at the end of this test. I am deploying an Nginx container into my Kubernetes, and I will be able to locally use that test localhost 3001. I think I should have the Nginx running there at any second, right? It runs in my K3s container that I can use. If I need, I can get the terminal into this and use it normally. For example, with the normal commands. So you can have all the setups. You can have, where's my Kubernetes? You can have all the setups. You can have any configuration that you need. And of course, that also works for GenAI applications. So this is what I want to show you. This is another Spring Boot application. It's a sample application. It does create a lot of AI components. It runs 2 chats in parallel, one with the content retriever to augment the chat with the RAG pattern for my content. And my content uses just a very, very simple embedding store using pgvector. So in my test setup, in my local setup, what I can do, I can have my pgvector image being run. I can augment that with the precise lifecycle. So in this case, I specify the container, like pgvector will be used as my embedding database. So I need my text storage be converted into vectors. That can take a little bit of time. So I augment my container setup programmatically with the checks. If I have my embeddings file ahead of time, which is usually here, I will copy that file into the containers, and I will execute the restore command for my database. So I don't need to recompute embeddings again and again and again. And then in my container, in my pgvector setup, I can also say that when the container is stopping, I can also execute custom lifecycle commands and run here, for example, that I created the dump with the embeddings. So together, you can have a very complex lifecycle. You can also, for example, create the images on the fly, Docker images, so you can run the Docker commands at certain points in the lifecycle. For example, if you run Olama locally and download the model into the container, it is 3-4 gigabytes, so it does take a little bit of time to run and pull, but you can, after that, commit the service, commit the Docker image, and next time use the latest Docker image to create containers already with models with the in. In general, it's a very, very flexible setup. You can run any technologies from stock common databases to browsers to anything. And you can work with your tools within containers locally as if they were installed locally with the Testcontainers desktop application. You can use any Docker environment, whether the cloud, Testcontainers cloud, or local Docker environment that you have. You don't have to use Testcontainers desktop application. It will work with any setup for you as well. And then it will work the same way for your tests and your local setup. And it will work the same way in CI. And you can run your applications in a natural way. So this is it. We are at time, and I hope it showed a little bit of what you can do more complex than just run individual containers. Test containers are amazing because you can get all those things as an API. Testcontainers Desktop provides the next level experience for you, and there is a bunch of resources that you can look and try. And please join the Slack if you have any questions. We'd be super, super happy to give you all the feedback and help you get better.
Well, Oleg, thank you so much. That was so great. So we had like a very active community, so the chat just went crazy, but we had Kevin who answered all the questions basically. So there were a lot of praises. People love test containers. The people who didn't try it before, you definitely made them interested. So they all promised they will check it out right now. So thank you for being with us.
Thank you for inviting me, and major thanks for Kevin for supporting me in the chat there.
Yeah, thank you. So keep the questions going in the chat. Thank you for enlightening us with test containers. It's also one of my favorite tools. We had a session together, I think 2 years ago. That went great. And I am a fan ever since. And whenever I use Quarkus, there is test containers with it. So, and for various other tools, just as you shown with Spring, it works fine as well. So thank you so much. And next up is Rory with Semantic Kernel. Hey, Rory.
Hello. Hi. Yes, I am feeling vulnerable because I hosted the APEC section though, but I have brought my game face. I've had enough caffeine to be illegal right now. So I'm hoping I don't come across as like my eye is twitching a little bit. And
so don't present and drive.
Yeah, no, well, I'm not driving now. I'm driving a computer. Oleg, great talk. And I'm happy to see you again here. And I love test containers. Test containers are an incredible solution when you are stuck without internet. Like I use it a lot of times. I just go switch off, does it work? And then I just run it and it goes, oh, wow. I didn't really think of that. So I switch off the internet and then I run it. And then I can actually say the application doesn't need something else external.
Yeah, absolutely. Thank you for the kind feedback. It's and if you're new to test containers, like you don't need to go and listen to me. Sandra and Rory both are big fans, and so are like literally thousands of other developers. Check it out, and thank you for the kind feedback. Yeah, it's like we hear all the time that if people sometimes talk about like what revolutionized their approach to development, right? And then, well, there is a bias, right? Because we are with test containers, so they of course want to say good things about us, right? But they very often are like, yeah, test containers is the thing that changed how we develop things.
You are the Netflix, okay? But I am going after you, so I'm going to take your vibe here, and I'm going to take that energy, and I'm going to try and apply it to that though, because I'm caffeined up. I want to go.
Very good. Please take it off me. Have fun presenting. Thank you.
Yeah, Rory, let us not stop you anymore. So go with Semantic Kernel for Java. It's actually for .NET, right? But you explain it to us.
It's Java. Java is the first class citizen. But it doesn't help that you brought in LangChain before that. So, okay, I'm going to go afterwards, but I'm going to make it really cool. So I've got a Yoda bot we're going to build.
Oh, nice. Go for it.
Okay, hi, everyone. My name's Rory. I work... Okay, we've got... Okay, there we go. Hi, everyone. I work with Sandra. And I'm a principal cloud advocate based out of Johannesburg, and we're going to talk about Semantic Kernel for Java. So what's the difference between LangChain and Semantic Kernel for Java? Basically, Microsoft really had opportunity to work very closely with OpenAI for a very long time, and we built a different paradigm. So whereas it's kind of like for like with LangChain, we have a developer-first approach that we've used that kind of fits in a little bit, and you'll see when we go through here into our approach. And if you know the Microsoft developer community, you'll see that a lot of it makes sense for that though. So who we are, so I've introduced myself, but there are hundreds of developers. So please join the Semantic Kernel Discord. So ak.ms/sk Discord. And there's a lot of contributors. It's a very vibey community there. And the tools that you like, Microsoft Office, Windows, Visual Studio Code, all of them kind of like plug into Semantic Kernel. So get opportunity to really use those tools and to contribute. So what happens? What's really good? And now we have AI orchestration. So we've got the apps, the plugin extensibility. You've got the copilots floating around everywhere. And then you've got your foundation models and you've got your AI infrastructure. But what we really need, and we've seen the industry really adopt it wholeheartedly, is AI orchestration. How did we get there from the beginning? So everyone started off just with a little old chatbot. So it's back and forth chats with the user. Then what everyone realizes, wait a second, these things can actually read text. So let's create the RAG pattern there, retrieval augmented generation for conversations grounded in real data. It basically says, here's a document and go read it. So it takes all documents. In the demo I'm going to show you today, very easy, one command, and you'll see how you can actually go in and create your own chatbot from that using Semantic Kernel. After that, we created something called a copilot. That's agents that work side by side with the user to complete a task. And you're seeing agents actually come into a lot of things. Copilot, GitHub Copilot actually has agents. It's got the workspace agent. And then finally, we've got fully autonomous agents that can respond to stimuli with minimum human interventions. And we're seeing that with the GPTs that are coming out in industry. So what is Semantic Kernel then? Semantic Kernel uses those, and the .NET version already is on agents, but the Java version is still kind of on the Copilot stage, and it's a lightweight open source SDK that lets you orchestrate native code with LLMs. So when I say orchestrate, it does it in a goal-orientated way. So I have a goal, I have an idea, and I want to go orchestrate the LLMs to facilitate. And we saw that also with Lizzie's LangChain session here. So it's grounded in Java 8, and we had some nice controversial statements in the comments with Java 8, but you can do Java 8+. It's available on Maven Central. It works on Android even, so you can plug Android with it. It uses a lot of the popular models, the open source model, OpenAI, Azure OpenAI, Hugging Face. It's open source on GitHub, so you can go in and utilize it right now. All the skills, the prompts are also open source. It's got an MIT license, and the samples available, they're based on all the way up to Java 17. It even works with Graal native images though. So it's really great. I want to start you off with two main concepts, models and memories, and then plugins. So models and memories, we've already kind of seen that generative AI, it's been a huge theme that we've had here. Memory really is, you can have semantic memory, and you can also have in-memory memory. The classic in-memory memory, which is just key value pair though. And semantic memory can be vectors in a database. So we're going to do that. We're going to actually load in some data, and we're going to look at how the data is loaded. And then once we have that, we can actually go and talk to that with plugins and trigger it with events with that, a chat event or a user chatting to the semantic kernel. So let's look at how we create a kernel. And don't worry, I'm going to recreate this also in the demos though. So when you actually do the kernel here, let's see if I can actually go in and annotate here with the mouse here. Let's go laser pointer here. You go kernel and you go, okay, cool, add some memory to it. So you want to add just a basic text memory here. Then after that, you're going to go in and connect to your settings. I'm not giving you my OpenAI settings, okay? I know it's expensive, but you're not going to get it. Then you're going to create the OpenAI client, and you're going to build an async client because we like streaming. Then you're going to do a text completion. Now, there is a text completion or a chat completion. So if you don't know the difference between the two, text completion is here's something, and it's basically a question, and then chat creates a conversation. And then you're going to return the kernel there. So kernel with memory and you've got your default AI service completion and build. Now, what the kernel really is, it's kind of like an agent, a brain. And then once you have it, you operate on the kernel and you say, kernel, do this, kernel, do that. And it kind of like is your babysitter, and it keeps you kind of grounded on what you want to do. So let's have an example with a plugin. So here's a plugin, and these are the OpenAI standard plugins. We originally started with something called skills. So if you go into the previous repo, the versions, you'll see skills, 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 skills. They were like meta prompts. And we're going to look at exactly what a skill looks like. But we changed it recently to actually conform to the OpenAI standard. So here's a plugin called Writer Plugin, and it's got brainstorm, email gen, short poem, story gen, translate. And I'm going to ask it, the plugin, can you write me a short poem about living in Dublin, Ireland, and then create a story based on the poem? And now we send it to something called a planner. Now the planner is, and I'm going to demo that also, is something that actually runs the plugins in an order. You can choose it sequentially, or you can do it with a, whoa, black magic when it comes to that. It can actually make up its mind of what to do and what order to do that, though. So we're going to use this, and we're going to create a Yoda bot, and we're going to give it full reign to go in and speak like Yoda and create an email for me. And then at the end of it says, sure, here's a story based on living along the Grand Canal in Dublin, Ireland. So here's the code here. So we've got the kernel that we've already got and we've created. And then we go kernel, import the skill, and look for the search engine skill, add a native function to the kernel to call a search engine. So this might be Bing, or it might be Google, or another search engine. And then we also can add a semantic skill that can summarize the block of text. So in this case here, we're actually going to, you can see there, add a search engine skill. And here, we're going to just import a summarize skill that we've seen there. And this will be a meta prompt. And we're going to get the function summarize. And then we're just going to go run async. What is the tallest building in South America? And we're going to pass in the search and summarize. It's going to go out into Bing or Google. It's going to pull back what the tallest building in South America. And then it's going to summarize that prompt there with that plugin. Simple enough. So I want to go in a little bit more detail into memory, because memory is also part of the RAG approach. In here, we've got a arrays as list. My name is Andrea. I work as a tourist operator. I've been living in Seattle. And then we add that into a memory collection name node. We add that into facts. So once you have that, and we're going to see that when we do the RAG pull in data with a lot of PDF documents, you can go add your facts there about me, memory recall, where do I grow up? And then you can actually go there, kernel, invoke async, do I live in the same town where I grow up? And what it's going to do, it's going to pull back the facts using the kernel, connecting there, and it can actually use those plugins. No, I do not live in the same town that I grew up. So my family is from New York, and I've been living in Seattle for 2005. So those are the two concepts, the plugins and also the memory. How does that plug into the planner? And we're going to see now. So let's see the end-to-end flow. So we're going to start with the user's ask. And the user's ask is, please create a series of tasks to complete a marketing project. Once you're done, please summarize them and send them to my team. So email them out. So we can kind of see already what kind of plugins we need here. So we need a series of tasks to complete a marketing project. So we need an idea about marketing. Once you're done, please summarize them. So we need a summarize action or a plugin, and then send them to the team. So email or Teams, and we send them to them. So we got that ask. Now we're going to initialize the kernel and the steps ready from the planner. So we're going to ask a planner of our choice. Now we're going to go through how many planners there are though, but my favorite is the stepwise planner. It basically does all of that for you. And then that's going to connect. It's going to gather the skills. Remember, we did rename those skills into OpenAI plugins. It's going to go look at the context. So either in a database, into memory or storage. Might connect to Bing or a search engine, and connected might go to a database also. And then it's going to execute the steps and the running steps in the pipeline. Now, how it does this, I'm going to show you that, because we're going to go in and it actually starts to think. It uses goal-orientated programming, and it uses design steps to do that. and it results in new productivity. So all you really need is an idea. You need your plugins already defined, and then it will go in and do all of that there. And there's the new marketing tasks emailed with Outlook to your team though. We've had multiple evolutions of plugins. We've been working with OpenAI for 4 years now. In the beginning of generation 1, we had the action planner. So it would choose the single best action for a goal. So if you've got some skills or if you've got a connector, it will go in and then choose only one. We then moved over to sequential planner, generate a complete plan to achieve a goal. So basically a plan, and it was still kind of sequential, but it would choose multiple little tasks to run it. We're on the stepwise planner level. Now, we have the similar infrastructure for LangChain. So LangChain just brought out agents, and agents perform a very similar goal to the stepwise planner. And the stepwise planner will iterate on a user's goal until it's complete. It will go in and call on itself multiple times until it feels it's answered the correct question. Yeah, boom. When I first saw this, I thought, oh my gosh, it's AGI. What are we going to do? It's going to take my jobs. No, don't worry. It didn't take my jobs. I'm still here. So here's a planner here. You go import the skill. In this example, we've got a text skill here. We create a plan to achieve the goal. We go, in this case, a sequential planner. So it's going to do one after the other. And we pass it in the kernel. And then we go create plan async, write a poem about Joan Doe, then translate it into Italian, then convert it to uppercase. So it's going to write a poem, translate it, and then convert it to uppercase. It might not come on itself. It might not think about, wait a second, the poem can't be translated to Italian, and it won't actually go, it might not recreate the poem. And that's what a stepwise planner actually does. If it feels that the poem isn't really, pro-Italian or really can do that, it will go back and call the poem generator again and get the best result. It's kind of like when, if you've ever used ChatGPT, it's asking ChatGPT to think about what it's doing. And then you execute it with invoke async though. Once you have that, you really want to go to Azure and you want to go to the cloud. And I've got a present for you. I've got 80 templates that you can use with cloud-based templates, because it's a hassle. Which cloud service should I use in this code? What libraries do I need to use? Local dev environment, infrastructure. How do I run it? How do I deploy it? All I want is to run it on the cloud. I don't want all of that. Look at that infrastructure. That's the template that I'm going to show you now. I don't want to think about all of that though. So I just want to use the Azure Developer CLI. I want to go AZD init, AZD up, and if I want to monitor it, and if I want to add it to GitHub Actions, I've got just my app to the cloud, but just with one command. And you do that with Awesome AZD. So log on to aka.ms/AwesomeAZD, and you've got the OpenAI templates. And the template in one of the demos I'm going to do is the ChatGPT Enterprise Data with Azure, OpenAI, and Cognitive Search that uses Semantic Kernel and has end-to-end RAG and uses planners to actually go in and get your data. It's a lot to take in here, and if you can see there, it actually goes in and indexes the data there. It's got a storage account with some data then, uses Event Grid, takes the service bus, pops it onto Azure Cognitive Search, which is part of Document Intelligence then, and then indexes it there to get your chat app to be able to talk to it though. Yeah, it's a lot to take on though, but we have those, and it's not only available in Java, you can actually access it in JavaScript, .NET. We even have Python, Go, a lot of those in aka.ms/AwesomeAZD. And this is the example that you got here. And we've got here, you can see there, semantic kernel orchestration, function chaining there. And you can see there that it's using the retrieval mode, vectors plus text. So it's already indexed it here, and it's got it there, and it's already doing that. And we're going to show you that more in the demo. So for the demo here, we're going to go into two demos, a very basic demo that Copilot kind of helped me with a little bit, aka.ms/sk-code. You can download it there and just pop in your Azure OpenAI or OpenAI settings there. And then if you want to get started with Awesome AZD, all you do is you install the Azure Developer CLI. You just go AZD init and that there, and AZD up. And you've got everything that we're going to demo with that though. So let's go out of here. And let's just minimize that there. So the first thing I want to show you, and let's go into here. So I have to be brutally honest. I didn't actually create this. GitHub Copilot created it for me. So if I go into GitHub Copilot here, and I actually had a long conversation with it, and I said, and I used Copilot voice here, which is also, you can just go, let's go into here. You can just go Copilot voice there. And I said, go Copilot voice, go create me a Java class with the called demo stepwise planner. And I gave it the package. The class should have a main method that uses an OpenAI sync client and a kernel using SK builders. Import a writer skill and a new emailer skill into the kernel, and use the stepwise planner to create and execute a plan based on a question. The emailer skill should have a static inner class, and it calls get email address and send email. And then it will send the emails there. But the send email, actually, I want to use a function. So it's a semantic kernel function. It's basically a prompt, but you can do it in a native way. So I went there and I had a conversation, I had a little bit of tit for tat with that. And I love Copilot because I can actually talk to it and demo it also like this. So it's going to go, I'll give you what you want there. And it explains to me there. And then it writes it out there. So definitely go in and check Copilot voice and have a conversation with that. And it's going through the email address and the send emails. And that's the template that we have here. And if you see here, it's got the stepwise planner, new stepwise planner, and then it goes in and creates. And I've got the finalized demo here. Don't worry, I'm not that brave to actually do it from scratch. And I've got here, here's the question I want to do. So create a short four-line poem about dogs. Then translate it into Yoda speech, like, can speak like Yoda, I can. And then email the translated poem to Stephen. Who's the Stephen? So I've got the client. I create my text completion. I've got my kernel. I create my kernel like we've seen before. I import the skills. Now here's the writer skill. Now this is the writer skill that Microsoft supplies, and it's pretty simple here. Let's go into short poem here, and it's actually just in a prompt here. Create a short story or limerick to explain the given topic. Be funny and let your imagination run wild. Run wild. So I've got that there. And then I've also got an email skill here. So let's just minimize that there. I've got an email skill. And the email skill here, it's got an email, and I've got defined SK functions. So you can create native functions in semantic kernel. And then right at the end, I just go send email. It's going to do to subject and message there. And then I've got a nice little web server that I've created right at the bottom there that goes in and says, okay, cool, display the email though. Because I can't email it out to you people now. I don't have all your email addresses. So I'm going to go run here. And it's going to go in and talk to my kernel. Okay, cool. Here's a question. Create a short 4-line poem about dogs. And then it's going to have a conversation with itself. A brain of a brain, like a higher level of consciousness, though. It's going to have a long conversation, and it's going to go in, and it's going to say, okay, what skills do I have? There's the rendered prompt that I got, and I've got the writer skill. And then after that, it's going to go, oh, here's the poem already. In a world where dogs can talk and sing, they'll be the rulers, the canine king. But it needs to do more. So it's got the poem. Then it goes in and goes, okay, now I'm going to translate it. In a world where dogs could talk and sing, okay, so it's passed it in there, and it needs to translate it into Yoda. Next, I'll translate this poem into English using the writer skill translate. And now I need to get Stephen's email address from there, and then there it got it there, and it had a long conversation around it. Now it's getting Stephen's email address here, and it says here, the translation, it's even having, the translation function has slightly altered the poem, but it's still essentially the same English poem. Since there's no function translate into Yoda speak, this is the best bet I can do with the available function. It actually talks to itself, and it explains to you how it thinks. And here's the, in a world where dogs could talk and sing, there would be the rulers, the canine king. With a bark and tail wig, they would hold court, chasing tail balls, their favorite sport. It didn't actually translate it into Yoda. That's very interesting because it has done it before though. So in this case, then it didn't actually translate it, but I want to go back into the demo log here, and you'll see here that I actually did get an example. But it's very interesting because it didn't actually agree to me that it had a Yoda translator. So in a world where dogs can sing, and then you'll see here, now I'll translate this poem into Yoda speak using the writer skill. And let's see here. No, it didn't like it, hey? It now I retrieve, it really didn't like it here. And that's really good because it's thinking to itself, wait a second, it doesn't have a Yoda speak here. Oh, wait, in a world where dogs and sing dogs could, the rulers would be the Canaan king understood. With the woof and a wag, hold court they would, chasing tennis balls, their favorite sport in the neighborhood. Okay, so in this case, then it did like it, but it was arguing with me and arguing with itself. And that's the stepwise planner that you want to actually leverage off though. And it really is powerful. So the last thing I want to show you, we've got 5 more minutes here, is the template here. So I've got the template, I've got my Azure OpenAI, I've got the awesome AZD with the ChatGPT. And now over here, all I've done is chat with your data. So what does a product manager do? And you can get through it here. And what this does is it actually goes in and it takes the, let's go into here. It takes all those files, the data files, chunks them out, chucks them into Azure Cognitive Search. Let's go see what Azure Cognitive Search looks like here. So we can actually see that in the Search Explorer, it just looks like a bunch of numbers here, but it's vectors. It actually goes in and chucks it into vectors. And then right at the end, you can see here, I've got the end-to-end transaction. It goes, gets the chat completions, gets the embeddings from that, searches to see if those embeddings have any other data there, and then returns the chat completion. And then finally, at the end of it, we've got the product manager responsible for developing and managing the strategy. And you can go in here and you can select the developer settings. You can go memory, you can go orchestration, function chaining, and you can also go in here and you can go in and choose vectors and text hybrid. All of this is available on Awesome AZD though. So you can access that and that. So that's everything I wanted to show you today. So it's incredible here. So if you want to know how we're doing those little Copilot little buttons on Microsoft Office and Microsoft Windows, we show you exactly that. But we're doing a little bit of black magic because we're letting the AI kind of command the AI in that regard though. And sometimes it works and sometimes it doesn't though. But you can play around with that and see exactly how you can do that. And it'll do the best level approach from that and go back on itself and say, I have the right skill or I don't have the right skill. This is what I'm going to try to do, or this is what I'm not going to try to do. Okay, so that's everything from my side. I want to leave you with the call to action. So we've just released the version 1.0.0 release candidates here. And that's got OpenAI plugin spec, the kernel hooks, and the handlebars planner. The handlebars you can actually compile in JavaScript. I know I can't get used to the fact that you can compile JavaScript here. You can go in there and you can access it on the Java V1 there. And handlebars is absolutely incredible and fast as everything. So thank you so much. You can go into the code, aka.ms/sk code, the docs, sk-jdconfig, the tools, awesome AZD, and then the Discord. I'm going to see you in Discord there, the aka.ms/sk Discord. Thanks, everyone, and back to you, Sandra.
Wow, Rory, that was great. Thank you so much. And you even sneaked in Copilot chat and Copilot voice, no speech.
Oh, it's my buddy there, hey? That helped me write that code then. I don't think I could have written that emailer code by itself, though.
Yeah. And the email and also the command to generate the code for you.
Yeah. So I want to tell you a little bit of a secret. I actually generated the whole project with the workspace agent also. So when you go act workspace new, and I just gave it the Maven settings, and then it goes in and just creates it though. It's a little bit longer. I didn't have enough time though, but you can actually do that. So I didn't really code any of this, really. I just had a conversation with GitHub Copilot.
But you needed to have the conversation so AI can't replace us entirely, right? We had that question in the chat.
Okay, my kid's got to eat. I can't do that.
Yeah, that's great. Yeah, I also feel that AI can't replace us. You know, we still need to be the pilot here. It's just the co-pilot. So we have to advise it what to do.
And the thing actually gave me lip, and it said I don't have a Yoda speak though. So yeah, but it like it talks back to me now. Like, you know, I'm hoping LangChain does the same. Like you didn't give me Yoda stuff here. You don't get to speak like Yoda.
Of course it does. Yeah, and I mean, yeah, you can see it as a competition, but then for overall Java, it's just great to have multiple AI tools that help us being more productive. So it's great to have something like Semantic Kernel for Java, Spring AI, and LangChain for J. So we have like multiple tools, which will just lead to better quality products or tools to use for me as a Java developer. So I'm just
as
super
long as
happy
it
to
doesn't
have
get as
more.
toxic as Vim versus Emac, okay? Because that I'm not even going to mention that, and then you're like, yeah, okay, no saltiness.
Yeah. So great to have you here. Next up is what's coming up with Jarkarta EE 11, and there he is, Reza. Hi.
Hi there, how are you? Can you hear me okay?
Is it very early for you? We can hear you just fine.
It's a bit early, yeah. It's about 7 a.m. Not too bad, you know, since I have a 24/7 job, but this is not the unusual, fortunately or unfortunately.
So thank you so much for being with us here. Do you have another question for Semantic Kernel, or should we just give the place for Jarkarta EE?
I don't. Yeah, I'm all good.
Okay, then thanks a lot, Rory. You're here for us in the chat. Please keep it going, answer all the questions in the chat, and keep questions coming up. And then the stage is yours, Reza. Have fun with what's coming up in Java EE 11. No, Jarkarta EE 11. Sorry.
No problem. Thank you. Thank you, everyone, for hopefully attending this session. It's super early for me. It's about in the morning, as I was talking to Sandra about, but hopefully it's afternoon for you, so it's not too bad. So as the title suggests, I'll be talking to you a little bit about what's coming in Jarkarta EE 11. It's not just about that, actually. I'll possibly be talking about what's beyond Jarkarta EE 11 and also possibly how you can contribute. So if you don't know who I am, my name is Reza Rahman. In my day job, I'm Principal Program Manager for Java on Azure. I'll explain in a little bit what my involvement with Jarkarta EE is as well. It's sort of part of my role, but perhaps not so directly part of my role either. So we'll talk about that in a moment. So in this slide, I'll just talk about history. Since we only have 25 minutes, I don't have a lot of time to give you a lot of history and background, but I do want to give you a minimal amount, right? So if you don't know what Jarkarta EE is, it's basically the technology that used to be many years ago called J2EE and then Java EE under the GCP or Java Community Process. And there was a number of releases under JCP EE5, EE6, EE7, EE8. Those are all under the JCP, and now that same technology has been moved into the Eclipse Foundation, in my opinion, for the better. The Eclipse Foundation is a far more open and a far more open source oriented place to be doing standards-based development. And personally, I think it's a really great thing that such a significant part of the Java ecosystem that runs a lot of things actually under the hood, whether you realize it or not. Jarkarta EE is really everywhere. When you look at it from my lens, you can't have a Java ecosystem without at least some portion of the Jarkarta EE APIs. So such a big portion of the Java ecosystem moving into the Eclipse Foundation, moving into completely open source. And now, of course, we've had quite a few releases there as well. So definitely a proven concept, right? Probably one of the few successful cases of a large-scale technology like this basically changing ownership, more or less. So under the Eclipse Foundation, we've had Jarkarta EE8, which is binary compatible with Java EE8. Then we had Jarkarta EE9, Jarkarta EE9.1, Jarkarta EE10, which is a current release. And now we're about to have Jarkarta EE 11. I'll talk to you a little bit about Jarkarta EE10, not too much about the previous releases per se. And I'll mostly, obviously, be talking about Jarkarta EE 11 and beyond. Okay. So a little bit of if you will, tooting our own horn. We are, Microsoft actually is part of the Jarkarta EE working group, has been for a few years now. In case you are not aware, we're an enterprise member. We're actually voted into the steering committee as well as the marketing committee. And in fact, we are now driving the Jarkarta EE 11 release. My colleague Ed Burns hopefully is with you in the chat. He's a person that's actually involved in coordinating the Jarkarta EE 11 release. So this is, in a way, is Microsoft's way of giving back. Jarkarta EE 11, Jarkarta EE in general is very, very important from an Azure standpoint. We have many customers and many Jakarta EE deployments and growing on Azure. But this is a way for us to say, hey, we also want to give back. We want to do something for this ecosystem. We want to do something for Java developers. And hence, we are actively contributing back into the technology. And we're very much, I would say, part of Jakarta EE11, the Jakarta EE11 story as well. So another thing that entity or people that I want to mention that is very useful in this context is something called the Jakarta EE Ambassadors. This is actually an organization that I helped found some years ago. Basically, what the Jakarta Ambassadors do is the Jakarta Ambassadors do is basically it's a grassroots level user-based organization. It's a bunch of ordinary people, ordinary developers out there. They basically help move this technology forward. And one of the very important artifacts that the Jakarta Ambassadors produce is a contributor guide. So there was a contributor guide for Jakarta EE 10. Now there's a contributor guide for Jakarta EE 11, and there's going to be a contributor guide for Jakarta EE 12. And what this contributors guide basically does is that it puts together a bunch of ideas from the community and sort of says, hey, these are the realm of possibilities of what could go in the next Jakarta EE release. So in fact, when you look at this slide here, what I'm doing, and I won't have time to go over the contributor guide, but basically what this is that it's a superimposition of what is in the what was in the Jakarta Ambassadors Jakarta EE 10 guide, and superimposed upon it is the actual work that happened. So this gives us a view of what happened, what could have been done, and what's in the way. So this is a color coding. I know it's probably a bit harder to look at. Hopefully, when you look at the slides, it'll be easier to understand. But there's a bunch of work, but primary themes in Jakarta EE 10 were CDI alignment. So one of the key things that happened there is the @asynchronous annotation that used to be an EJB only, now is a CDI annotation. There's slightly better support for CDI in the batch API. And there's a bunch of stuff that we know are gaps that weren't addressed. So things like the @schedule annotation, lock annotation, so on. All of the rest of the stuff that you see here, that's what was not addressed. Similarly, for Java SE alignment, we had a completion stage that made into the platform in a managed fashion. We also had a bootstrap API for REST, where you can just start a RESTful server just from a Java SE environment. What didn't happen is a similar capability for messaging. A bunch of standardization gaps that were actually closed. So we now have standardized version of OpenID Connect, not JWT alignment yet. That's happening now. There was a job definition API that could have happened in the batch standard that didn't really happen. Manage executor definition happened. Some more SQL support in JPA, multi-part form data in JAX-RS, all of that happened. There was also a brand new profile introduced called the core profile. That was also something that the ambassadors in particular had been waiting for some time. This is basically geared towards more lighter weight, more modern, next generation Jakarta EE runtimes like Peloton and Quarkus and so on. And then finally, a bunch of deprecation, right? So there's a bunch of deprecation that happened in Jakarta EE 10 as well. And in the Jakarta EE 10 timeframe, there was a number of new specifications that were on the horizon, namely repositories, NoSQL, MVC configuration, and gRPC or RPC, right? So now fast forward into Jakarta EE 11. So this is, again, it's the same exercise where we've taken what was in the Jakarta EE 11 contributor guide and now superimposed it on the work that already has happened. And you can get a similar picture of what has already happened, or more precisely, what's on the way, and what are gaps. So the @schedule annotation was left over from Jakarta EE 10. That's actually possibly happening in Jakarta EE 11. Roles allowed is another one that could make it into the security specification, quite possibly. Slightly better alignment with Jakarta REST with CDI, that is possibly on the way. What has definitely happened is adapting to Java SE records, adapting to virtual threads. I'll talk about these in a little bit more detail in a moment. There's always modernization and work going on in the TCKs under the hood. You don't see that in the API level, but from the provider level, we can see that that work is happening. And again, a lot of more things in the deprecation chain, right? So things like JAX-WS or SOAP support was deprecated. XML support or JAX-B was deprecated. There was Corba support was finally deprecated after many, many years. Managed bean was an annotation that really wasn't used very much, so that's deprecated. In EJB, hopefully is on the way to being deprecated. It's not deprecated yet, but hopefully it's on the way. So it's that's why it's in black. We can call it a gap, if you will. So in terms of the new specifications, the one that absolutely is on the way is a repository spec. The rest of them, namely NoSQL, MVC configuration, they're in various stages of development or being treated as candidate specifications. So they're not quite included in the Jarkarta EE platform yet. They're basically being treated as candidate specifications. So NoSQL is one of those. It's a relatively mature specification, but not in the standard yet, but it could be in the future. Same thing for things like MVC. Configuration on RPC, gRPC, on the other hand, is on the way. It's being developed. It's too early to even consider a candidate specification for E11. So leveling up for a moment, this is how E11 really looks like. This is the major themes. So first and foremost, when is it going to be developed? When is it going to be delivered? The answer is very soon. It's in the first half of 2014. I would project probably late summer. We will actually have a Jarkarta E11 release. And just so you know, one of the requirements of the release is you have to have at least one runtime. So there will be at least one runtime that you can experiment with Jarkarta 11, maybe even two. My prognosis is probably it's going to be Glassfish and shortly thereafter Open Liberty. So you may have two runtimes to experiment with Jarkarta 11. The baseline has increased. So the baseline for EE10 was either SE11 or SE17. For Jarkarta 11, the baseline is either 17 or 21. So it depends on whatever it is that you want to choose. If you want to use E11 with 17, you can, but you also have the choice of running it with 21 if you so wish. So along those lines, there are some changes that were absorbed by the specification. So I mentioned this slightly before. So namely records, virtual threads, and security manager deprecations. For those of you who are not aware, in 21, or actually in 17, the security manager was deprecated, and there was a bunch of dependencies on various specifications on the security manager API. So that part is now essentially taken care of across many different specifications. All of those specifications have removed the references with security manager and replaced it with something else. There are some specification updates. I'll talk about that in a moment. In particular, the ones I'd like to call out is the persistence spec. You may know it as JPA. Concurrency, CDI, and validation. You may know validation as bean validation. The new specification we already talked about, data, or other repositories, or data, more specifically Jarkarta data. And then we talked about all the deprecations, right? So these are one up level. This is basically the high level themes of Jarkarta 11. All in all, I would say a modest release, right? So there's not a tremendous amount of stuff in there, but there's a decent amount of stuff in it. There's a decent amount of interesting stuff. Even if you don't happen to be using an application server, I think there is stuff that you would be able to adopt. Okay, so now let's begin a quick tour of the precise changes, right, that we're talking about. So spec by spec, right? So first spec I want to talk about is Jarkarta concurrency. The main change here that is absolutely for sure is that Jarkarta concurrency is adapting to virtual threads. What that means is that when you create a managed thread using the Jarkarta concurrency API, it used to be that you can only use native threads. But now you can actually very easily, just with a one flag, say, hey, when I want managed threads and I want to use them in my application, I want those to be virtual threads as opposed to actual physical real threads on the JVM. The other thing that I think will miss it this time, but it's almost there, is the app schedule annotation. Again, that if you're familiar with EJB, it was in the EJB spec. Now it's being moved into the concurrency specification, and it basically can be used with any CDI bean, right? So it was on the way. I was like, okay, is this going to miss it? And it did. I think it's going to miss it, but should be available in Jarkarta 12. Okay, so this is a quick example of what using virtual threads with the concurrency, with the E11 concurrency looks like. Basically, it's just one attribute, right? When you're creating a managed executor or a managed executor factory, all you need to do is say virtual equals true, and that will give you under the hood virtual threads if they are available as opposed to native threads. Okay. Jakarta persistence, there's a long laundry list of features that were here, and they sort of got shrunk over time. The ones that I think are absolutely certain at this point is the support for Java SE records as JPA embeddable classes. I think that will definitely make it. I believe it was something that also will very likely make it is a deprecation of the old datetime APIs. So if you're familiar with JPA, you can use date, time, and timestamp, and you with the temporal annotation. But that's being deprecated because it doesn't really make any sense anymore with the new datetime APIs. So it'll be deprecated in favor of the datetime APIs, which were supported in Jakarta E8, actually, in Java E8. So we've had datetime support for a while now. It's time to sort of deprecate the old ways of doing things. There were more SQL-like things that were on the docket. I don't know how many of these are going to make it in. I hope some of them are going to make it in yet. There was also talk about creating better support for subqueries. I don't think that's going to make it, so that's going to probably flow into EE12. And then similarly, there was some decent amount of conversation of being able to use an entity manager API in CDI context, using the @inject annotation in a thread-safe way, as opposed to using that persistent context annotation. So that didn't make it, but I'm pretty sure it's going to make it in Jakarta E12. Quick example of using embeddables as records. So hopefully you've seen embeddables before. That's on the top, you see an example of that. And basically, you can use that record exactly as just like you would an embeddable portal. Relatively natural and straightforward thing to do, I think. So Jakarta data, what is it? I think it can be straightforward. So if you've used Delta Spike data or Spring Data JPA, it's the same concept. So basically what the Jakarta data API does is that it auto-generates repositories for you. So it auto-generates it from implementation. So you have an interface, you define what the interfaces look like. The interface follows certain semantics, and then you put annotations on it, and at deployment time, lo and behold, you have essentially something that works automatically. So the container generates the repository based on that annotated interface on the fly for you. The idea here is to use it for both Jakarta persistence, which remember is geared towards RDMS, relational databases, and Jakarta NoSQL. But for now, right for now, it's only Jakarta persistence. But no reason to think that Jakarta NoSQL would also not adopt Jakarta data. In fact, there is some amount of work that is going on to do exactly that. Okay, quick example, hopefully not too exotic. You've seen this before. So let's assume you have an entity. It's the same way that you always do. And then you mark up your repository. And again, it's an interface. You mark it with @repository, and then you have these sensible semantics for naming of what you want these methods to be. So in my example here, I have essentially two finders. So this is the semantics, and it's not too unusual. If you're familiar with either Jakarta data or Spring Data JPA, very similar sort of syntax here. So there are some other bucket of changes here that happened in Jakarta 11 as well. I'll talk about it in broad brush. I don't think it makes sense to talk about spec by spec. I'll sort of talk about it holistically, what these things are. So just like you saw that there is Java SE record support in JPA, namely to create embeddable classes, there's similar sort of opportunistic changes in Jakarta validation, or what you probably know as bean validation, CDI, and EL. So those also, to some degree or the other, now are sort of Java SE records compatible. They're able to work with Java SE records. Managed bean deprecation, I already talked about. This is similar to where we had these sort of oddball annotations. JSF had a managed bean annotation that was deprecated in Jakarta 8. There was this other managed bean annotation in the commons. In the commons namespace, hardly ever anybody ever used because they were just using CDI. So that's now gone. That's deprecated. And basically, the idea here is to streamline the specification, to streamline the platform as much as possible. This is why all these deprecations. And hopefully, I'm hoping, soon enough, we'll also be able to say, hey, EJB is also at least deprecated or superseded. You don't need to use EJB anymore. Already talked about the Java SE Manager, Security Manager deprecation. So probably it doesn't impact you. A lot of the Security Manager APIs developers don't use directly anyway. It's more of an implementation concern. But all of the places, all of the specs that made use of that, that's all deprecated now. And basically, there's replaced by something equivalent. But for the most part, probably not much impact for you. Now, one of the things that I had been waiting for a while, just in the spirit of making everything sort of CDI flavored and not having different versions of dependency injection in the platform, is the add context annotation. So for those of you who have used Jarkarta REST or JAX-RS before, there's this sort of one-off annotation add context that basically does the same thing as at inject, CDI at inject. So there's been work for a while to essentially deprecate that and do exactly that, get rid of add context and replace it with that CDI at inject. Again, did not happen this time. It's well on the way, but what is definitely happening is that there's the add context annotation. If you use it in EE11, you will get a deprecation warning, meaning that in Jarkarta E12, most likely the add context annotation will go away and will be replaced by at inject. So it's a good time to begin thinking about what you want to do with the add context annotation and be prepared. In the next release, you are going to have to do a port from away from add context into at inject. Another small one is, oddly enough, you were not able to use the at priority annotation, which defines the injection priority of components in CDI producers. So if you ever use CDI producers, this causes a little bit of a headache. You kind of have to work around to figure out, okay, how do I, if I have multiple producers that produce the same object, which one actually gets injected? So that is now, you can deterministically do that by assigning the at priority annotation onto the producer methods themselves. So it's a kind of a nice thing if you make heavy use of producers. Very brief example. Here's how the integration with Jarkarta records and bean validation looks like. So again, here's an example of a Java SE record. If you want to validate this record, let's say in your JAX-RS endpoint or Jarkarta REST endpoint or JPA endpoint, this is how you do it. Right? It's a simple matter of just annotating, annotating the Java SE record with the bean validation annotations, and it'll work just like as though it was a poacher. Okay, so that's about it in terms of a summary of where we are in terms of Jarkarta 11. So a decent amount of stuff. Hopefully, I'll find a way to share this deck with you. You can take a look at it. And even if you don't, you can't see this deck. Actually, a more extended version of this deck is available in my speaker deck. So if you look up my speaker deck account, you will see a deck that says Jarkarta 11, and that will give you actually much more details and much more about the possibilities. In the short time frame, I did truncate it a little bit, but as you saw, there's a decent amount of stuff that was there, right? That we were hoping was going to make it into Jarkarta 11. Not all of it made it in, but there's still a good bit. Right. I think as you saw, even if you're not using an app server, there's a good chance that some of these changes are going to be relevant to you, whether that's the bean validation annotation changes or the JPA changes or simply some deprecation, or if you are using the Java EE APIs, there is actually quite a bit more for you, right? So there's again the changes in CDI, the changes that are happening in JWT that I didn't quite get a chance to mention. Basically, the way JWT is being supported is that it's going to be supported by microprofile, and of course, being able to use a brand new spec Jarkarta data. I think it's been long overdue. So a decent amount of stuff in Jarkarta 11. But one of the things I did want to mention is, and this is the reason I sort of mentioned, the things that didn't make it in. Is that one of the objectives that we always had in moving things from the JCP into the Eclipse Foundation is that you, as a developer, would be more easily be able to contribute into the specification. So the JCP has quite a bit of red tape around that. The Eclipse Foundation does not. Right? It's mostly the specification projects look like any other open source project. So if you want to make any of those things happen, the things that I mentioned that didn't make it into necessarily into Jarkarta EE 11, but could be Jarkarta EE 12, and some of those are on the way, you can actually help make some of that happen. And that is really what the contributor guide, the Jarkarta Ambassadors Contributor Guide, is designed to do. So last thought I want to leave with you is that if you actually want to contribute into any of this, you can always reach out to me or reach out to Ed or reach out to any of the Jakarta ambassadors, and we can help you figure out how to contribute yourself into Jakarta E11 and Jakarta E12 and beyond. So I'm going to leave you with there's a ton of resources out there. I won't mention them, all of them. I will just give you a small set of resources to leave with you today, especially if you're not super familiar with Jakarta EE. These are the ones you want to get started with anyway. So these are officially, if you want to find out more about Jakarta EE, the best place to do that is jakarta.ee. There's actually a starter that I helped develop as well, the Jakarta starter. If you want to, if you're just a beginner and you want to get started with Jakarta EE, go ahead and try out the starter. It's on the Jakarta EE homepage. One way that I feel is a good way to connect with the community is being part of the mailing lists. And if there's one mailing list that you should really be a part of, if you're interested at all in Jakarta EE, is a Jakarta EE community mailing list. Right? So I've sent a link to that. There's plenty of other mailing lists. That one, I would say, if you don't follow any other ones, please do that one. There's similarly, if you don't follow any other thing on Twitter, please at least consider following the official Jakarta EE handle. The most important stuff that the Eclipse Foundation puts in that Twitter handle. So consider following that, even if you're, maybe not necessarily interested in Jakarta EE contribution, at least to have the awareness that X or Twitter handle is a useful thing to think about. If you want to learn Jakarta EE, there's an official tutorial. I didn't put it in the link. I think actually most people like learning through videos, at least certainly I do, especially if I'm getting into something. And there's a lot of very good content, from very beginner-friendly content to very in-depth content that is in the Jakarta YouTube channel. So I have left a link for you there as well. So finally, I'm going to sort of wrap up the presentation and take a few questions from you, and I'll also maybe have a little bit of, hopefully have a little bit of indirect dialogue with you. But one of the reasons we do this, both Ed and myself, is actually to connect with you. I'm not an advocate per se. I'm not my day job. I'm a program manager. But the reason I do these talks is actually to connect with you, right? In one way or the other. In this case, in the context of hopefully Jakarta EE, at least getting your thoughts on what's in Jakarta EE, and maybe even help you become a Jakarta EE contributor in one way or the other. So the way you contact me, honestly, is very simple. I'm very easy to reach. It's this URL. I don't know how to make it any more simpler. It's simply reza-rahman.me/contact. So that's yours truly at the .me domain, and then the page contact. And however you want to get in touch with me, please do so. Always look forward to speaking with you. So that said, I think we can wrap up the presentation. And what do we have, Sandra? Do you have some questions?
Thanks, Reza. So there are a lot of phrases and people want to know like more things, but Ed answers them all already. So they now wanted to go like deeper, and they wanted to know when the specification will come out. Ed already replies it's going to be in this summer, so in June, July. So we're really much looking forward to see so. Yeah, thank you so much for being with us. And for everyone watching, we also have a survey. So here it is. So please take a moment to complete this brief survey. And here's the event code. And remember, we also have some rewards to share for everyone who completes the survey and who is with us today. So that's really great. And yeah, next up will be Alina for GraalVM.
All right, I wish Alina good luck. Thank you for having me, and have a good rest of the day.
Thanks, Reza. It was so great having you. So we just went from Java EE or Jakarta EE, enterprise specifications and enterprise new tooling to GraalVM. So lightweight, up to speed mode. So I can't wait to see what you have for us for Spring Boot applications with GraalVM. Alina, I can't hear you. Can you check your mic? I love this new bunny, by the way. It's like the new icon. I mean, new. Saw it at DevOps Belgium last year first, so it's Super cool. I also have a t-shirt with it. And I also have a hat for this JDConf thing. Let me just fill some time until Alina made sure we can hear her.
Is the sound any better?
Yeah, now I can
you
hear
hear me
you
now?
very clear. So the stage is all
Sorry
yours.
for this. Virtual conferences are complicated. Sorry for this. Okay, I hope you all can hear me, can see me. Thank you so much for coming to the session. My name is Alina. Oh, what's going on? Yeah, all good. Hi, everyone. My name is Alina. I'm a developer advocate for GraalVM at Oracle, and I'm here to talk with you about GraalVM and Spring Boot and how you can build fast and very lightweight applications with both of those projects. And I'm very happy to be back at JDConf. I was here, I think, 2 years ago, had a lot of fun, and I intend to have fun again. And I hope you will enjoy this session as well. So let's go. Okay, so let's talk about GraalVM and specifically about native image, because that is the part of GraalVM that kind of helps us build those fast and lightweight applications that are also very slim, use very little memory. So GraalVM itself is a JDK, like any other JDK you might be using before, and GraalVM just kind of builds on top of it and adds more to it. So you can still run applications on GraalVM as a JDK. You can just use Java command, pass it to your application, and it will run on the JVM. The only thing that will be different in that scenario is that we will use a different, our own optimizing brand new Graal compiler. So that is one part of the Graal story. That is just-in-time compilation, where you can run applications very fast on GraalVM as a JVM. And I'm here today to talk with you more about this other part, and that is the ahead-of-time compilation, where you can build applications that no longer require a JVM to run. So they are fully built and fully compiled and even optimized at build time. So you might have heard of GraalVM's native image utility, and that is the part that we are talking about here. But before we dive into it, okay, this is not clicking, so I would need to click on this screen, but no worries. So before we talk about GraalVM and where it is now, I just wanted to bring up this nice visual slide that we have of the history of the project, where we started working on GraalVM very long time ago. So when Thomas Yurtinger, our project lead, joined, I think it was Sun back then in 2011. No, it was Oracle already. So that's when the project originated and where we are now. And you can see that over the years, we did a lot of work, but also we saw, luckily, a lot of adoption from the Java and the wider development community. And that is one specific time milestone on this timeline that I want to emphasize. And that is the one over here, where Spring Native as a project went beta. So it wasn't GA yet, but Spring's integration with GraalVM that was first introduced as a separate Spring Native project was first available to users and kind of ready to use as a beta release back in 2021. So we did a lot of work since then, but the reason I'm showing you this, as I want to make this point that as it might seem rather new maybe for some people, you know, GraalVM and specifically the integration with Spring, but in fact this is something that has been around for a while, and that something that we worked on with the Spring team for a long time, and now we are happy that it's also available as GA release and you can use it safely in production. Now, let's briefly talk about native image and how it is even possible to compile applications ahead of time, and more specifically Java applications, because we know that Java applications are highly dynamic. There are a lot of things going on at runtime. So how is it possible to produce a native executable version of it that doesn't need a JVM anymore? So what happens here is that when you run the native image command and you give it an input, so the input could be a class file or it can be a jar, but has to be bytecode level. So when you give it your application, we will analyze your whole application, also including its dependencies, such as JDK classes you might be using and even dependencies in your own project. Then we will analyze this whole thing, compile it, and produce a native executable version of it. And there are two important things here, and two things that make it different from running applications with the JVM. One is that there is no longer a JVM to run. So this application is fully native running on its own. This way it can use way less resources, memory, CPU, because the idea that we have is that we are moving all of that work from runtime to build time. So when you run your application on the JVM, you might have noticed, especially if you have a larger application, then when you want to start it, it can be sometime, maybe 1 second, 2 seconds, 3 seconds to start. And that is because JVM has a lot of work to do when you start your application, make sure that it runs correctly and it can achieve that great peak performance. Now, the idea and the trade-off that we want to offer you with native image is to move all that work from runtime to build time so that you can do it once and then start much faster every single time, because it seems like applications are starting and running more often, way more often than they are built. So such a trade-off to move that work to build time makes sense. That's one important thing to understand. And another thing is that we will eliminate everything that you are not using. So we will include in this executable only your actual code and your dependencies code, the parts that you're actually using actively in your application. And that is to strip down everything you no longer need to produce that small, compact, native executable. Okay, but let's talk about how GraalVM meets Spring Boot and the benefits of those two projects together. So I mentioned before that beta release was available, I think, in 2021, right? And then in 2022, so 1.5 years ago, Spring Boot 3.0 went GA. And one of the major features in this release was actually GraalVM native image support. So ever since Spring Boot 3.0, you can use native image immediately in your Spring application without any additional work to be included from your side. You just need to add it as a dependency. And speaking of that, this is how easy it is to add native image support to your Spring Boot application. When you go to start.spring.io and you click Add Dependencies, native image is actually the very first thing you see there. And that will enable building those native applications, testing, etc. But enough talking about it. Let's see some code and let's try and build such application ourselves. Let me just switch here and hide this. And I'll probably also zoom in a little. So what we have here is a sample Spring application that I went and just generated at start.spring.io. And I added one more endpoint, so that is something that we can look at. So let's run it and let's see what else we can do with this app. So first, let's check our Java version, make sure we're also running on GraalVM. So yeah, seems good. We are running on Oracle GraalVM version 22. So this is as new, as fresh release as it can be, because we only released it along with Java 22 release, 2 weeks ago, I think. So let's run this app. And as I said, a normal Spring app, so we can just run it like so. So Maven Spring Boot run. Okay, looks good to me. And as I mentioned, GraalVM is also a fully, completely working, capable JVM, so it can run on the JVM as well. But let's see what our application does. And for that, let me just grab another browser tab. Let's go here and let's check on our app and what it does. Okay, so it shows our output, the one that we expected, saying hello from GraalVM and Spring. Looks good, but let's see what else we can do here. So if I go to my POM.xml, I will see a number of things there because I'm also using this demo for other purposes. But for the sake of this session and this demo, let's look at this part. And this is native Maven Pro plugin coming from GraalVM build tools. So this is something that Spring will include in your project when you add native image as a dependency. And this is a Maven plugin, but also we have a Gradle one, and both of them are developed by our team, coming from our team, and those are the plugins that will help you build applications with GraalVM. So let's see if we can build it as a native app, and let's do the following. So Maven, I want to pass the native profile, and then I want to instruct it to compile to native. Let's do this. And as it is compiling, I want to illustrate a couple more points in this POM.xml file. So as I said, I'm using it for other demos as well. And that's why you can also see that here we have one profile that is instrumented. So this one I'm using to build an instrumented version of my application. And then with that instrumented version, I can build a fully optimized version. So this feature of GraalVM is called profile guide optimizations, and that is the way to bridge that gap between runtime and build time and collect that profile information that JVM obtains at runtime and feed it to native image at build time so that native image can optimize specifically for your application's behavior, because now it has awareness of which methods are more hot, which loops are more often executed, etc. So with this optimization, specifically PGO, we can reach performance that is comparable to the JVM, and we will look at that in a second. And also, there are a couple more things in this project. You can build an application that you can then monitor. So you can do things like GFR. And then we can also produce build reports that help us better understand what's in our application and how our build process went. Before we switch to the actual application, look at it again, I just want to say that if you want to try something that I'm showing here today, but also if you want to experiment with native Spring applications more, this project that I'm showing you and way more is available on GitHub on my private page. So you can go and check it out, and hopefully this README will be helpful for you for building an application like the one I'm building, but also trying other capabilities of GraalVM as well. But now that we were speaking, let me move this up and let me clear this. So let's see what we now have generated. And for that, let's look inside our target folder. And we see a number of things there, but one that is more interesting for me is this plain demo application that is freshly generated just right now. And we see that that's a native executable. So let's kill the previous one that we were running, and let's now run this application as a native executable. Okay, it's starting. I also did not point it out in the JVM run, but maybe if you were paying close attention, you might have noticed that the JVM version of this app started, I believe, in like 1.2 seconds or so, which is maybe, not that bad, but I think we can do better, right? And now with native image, we can see that our application starts in just 45 milliseconds. But it just starts, so let's see what it actually does. And let me grab another browser tab. So if we go to our local host again and the same endpoint, we can see that this application does the exact same thing that we expected it to do. And obviously, you can build this application further, add more capabilities, add more libraries, add more features. But this is a good starting point for building Spring applications with GraalVM. So let's go back to the presentation and let's see what else we got and what else can be helpful for you. Yeah, we looked at the demo. I want to talk a bit about how Spring works with GraalVM. And that is this new concept in the Spring ecosystem now called Spring IoT Engine. So the reason that this is needed is because normally when you run your Spring application on the JVM, it does a lot of work at runtime by pulling all the different configuration and sources of information from your app to build this kind of internal understanding of your application, pull things together, and then run them together. And what's interesting, GraalVM native image does kind of a similar thing, but it does so at the build time. So the runtime hasn't happened yet. And it was kind of interesting to see how that was resolved, bridging this gap between Spring's runtime configuration and GraalVM native images build-time configuration. And that is exactly what Spring IoT Engine is there to solve. So it transforms your application in the way that it's friendly towards GraalVM native image and easier to process for GraalVM native image. And as part of that, it also produces a number of things for you, so you don't need to worry about them. It will produce source code for you, it will produce bytecode, and it will also produce so-called hints for native image, so configuration files to make certain things work with native image. This is not something that you normally need to worry about yourself. I just find it interesting how this integration came to be and how Spring and GraalVM work under the hood. Okay, and talking about building applications and building with more libraries, one of the questions that I get quite often from people who want to try GraalVM is saying, okay, I have this existing app and I want to try it with GraalVM. So how do I know if I should proceed with it? Like, can I maybe evaluate looking at my project? Let's say it has a lot of dependencies. Can I evaluate easily without even trying if that will work well on GraalVM? And for that, we have this very helpful page on our website. So this is on graalvm.org, and this is called Ready for GraalVM Native Image. And this is a list of libraries, frameworks, tools that are known to be working with GraalVM Native Image and that are actively, regularly testing to be compatible with GraalVM Native Image. So I would bet this list is in reality much longer, but those are definitely the ones that are known to work and test with GraalVM, because maintainers or users of those libraries have contributed this list to our repo. So as a rule of thumb, I would suggest that you go to this page and evaluate. And if you see all the dependencies here, then things will definitely be great for you. And if you don't find a dependency here, it might still work. It might be just like not contributed yet and as an item to this list. But this will be one helpful thing to know if you want to build the application as a native image. Now, in terms of testing, there is also very good support for testing application as native images. And specifically, JUnit also supports testing with GraalVM native image through the frameworks, but also directly. And, I showed you a brief demo, but we are focused mostly on the startup time. And working on a compiler, one thing that we care about a lot is peak performance, because we know that this is something that we all know and love about Java and the Java ecosystem, and how our Java applications are always running very fast. So our big goal, a very ambitious one, is to bring the IoT performance on par with JET. So we want to make sure that when you're running with native image, in addition to fast startup time, in addition to low memory usage, low CPU usage, you also have comparable performance with the JVM. So you are not losing anything, you are just gaining additional benefits. And to illustrate that point, we took a Spring Pet Cleaning application and we ran it on GraalVM as a JVM. And we run it on GraalVM CE with C2. So that is effectively your OpenJDK setup, because C2 is that JET that you have in OpenJDK. So the blue bar, that is effectively OpenJDK setup, and then the orange one, that is Oracle GraalVM native image with full optimizations. And we can see here that the performance of native image in terms of peak throughput is on par with C2 and even slightly higher in this case. So this is an ambitious goal, but we are getting there, and we think that we can make all applications, or maybe a majority of applications, run compatibly fast on native image, in addition to all additional benefits. Now, peak throughput is good, but I want to mention slightly the cloud angle and the resources usage. So either when you're deploying your applications to the cloud, or maybe you just have concerns about how many resources your applications are using, and rightfully so. So maybe you want to limit and reduce those resources usage as much as possible. Native image can also help you there. So on this chart that we are looking at, it's a bit complicated, but bear with me, we can do this. So what we are looking at this chart is operations per gigabyte per second mapped onto XMX settings of your applications. So operations per gigabyte per second, as the name suggests, shows you how many operations can your application perform with the given amount of memory in a given amount of time. So some people call this throughput density. Basically, that is how much of valuable work you can get done with this amount of resources and this amount of time. So memory efficiency and the throughput that you get per those resources. And then we map those onto XMX settings, because we saw that there is slight difference in how efficient your application is in utilizing resources, depending on how much memory you give to the application, which makes sense. And this is, again, run in Spring Pet Clinic. And two observations that I want to share from this chart is that if you look at the orange bar, that is the GraalVM native image line, and you can see that when it comes to memory utilization and getting work done per amount of resources, it's consistently above C2. So it doesn't matter how big or small your application is. With native image, you will utilize your resources better, because as we've seen before, peak throughput is still good, but you can use much less memory. And another interesting observation here, if you pay attention somewhere around, I would say maybe 512 megs, there is this sweet spot where native image looks, I would say, almost 2x as memory efficient as C2. So this shows for me personally that for applications which may be like, I would say, medium-sized heaps, so maybe 512 megs or up to 1 gig, that is the absolute sweet spot where native image gives you great throughput per memory. And even if you have a large application, it will still be better. But for those medium heaps, it's absolutely winning against C2. And there could be many more performance metrics. I will not stop here, but I just want to say that maybe if you care about latency, let's say, and you want to make sure that you can have great latency metrics with native image, that it's also possible. So let's say you have some strict CLI that you want to meet, and then you can also meet it with native image because it can have even better latency than the JVM. So yes, wrapping up this story about using GraalVM for cloud applications and why would you be caring about GraalVM and specifically native image, one benefit that we saw also in the demo is fast startup, where application starts much faster because it was already built and compiled at build time rather than at runtime. Now, we also talked about low resources usage, and there I would specifically emphasize memory usage because often that is the quite expensive resource in the cloud, I would say, but also the same applies to CPU usage and even electricity. Just because native image does way less work at runtime than the JVM, it can help you use way less resources and still get the job done. Now, another interesting angle of native image is predictable performance. And again, this is related to the cloud because maybe you want to have more kind of flat resources usage profile rather than having those, random spikes. And native image gives you kind of very stable, very predictable performance because there is no compilation, no class loading, etc. happening at runtime anymore. And I also like how the Spring people call this metric. So they called it instant performance because native image doesn't need to warm up. So as soon as you start the application, it's fully on, fully compiled, and ready to serve your requests. Now, native image also has an interesting additional security layer on top of normal JVM deployments, and we will talk about that in a second, as well as compact packaging. And there is also, it's also very easy to build applications with native image because all the major frameworks, all the major cloud vendors in their SDKs, they all support native image and they all give you tooling and support out of the box to build applications with GraalVM. Okay. And yes, I want to talk about packaging a bit. So if you want to have very small, slim applications, maybe you want to have small container images with GraalVM native image and using static images, so fully statically linked, you can go absolutely to low numbers. So comparing to the JVM, this is the same application, just packaged differently. And you can see how you can take your image size from somewhere around 400 megs to as low as 18 and deploy it on distro list. So if you want to have compact packaging, there is also one thing that native image can do for you. Now, I do want to mention GitHub Actions and CI/CD systems in general. And the reason why I mention specifically GitHub Action is because I like GitHub Actions, but also we have our own GraalVM GitHub Action that you can use in your projects. And one way that I can see that being particularly helpful for GraalVM and working with native image is that if you want to produce cross-platform builds. So native image out of the box does not do cross-platform builds because we need some JDK classes that are specific to the platform. So I cannot build, let's say, application on my Mac for my Linux cloud instance. But with CI/CD systems, it's possible. So you can just build with them and produce native executables for all the platforms and all the places that you might need. So I would recommend checking that out and also checking out our GraalVM GitHub action. It helps you pull all the latest GraalVM releases and even early access builds, and are also available with the GitHub action. So strongly recommended. And I want to mention briefly that security angle of native image, because I think this is not talked about enough. Usually when you hear GraalVM and you hear native image, you hear things like fast startup, low memory usage. Maybe it's great for things like, CLI apps and serverless, but there is also an interesting security angle in native image. And that is coming from the fact that, as I mentioned, native image built to application at build time, and there is no longer dynamic class loading at the runtime. So everything is precompiled, everything is packaged in this native executable. And then things like reflection and serialization in native image, in most cases, require a specific allow list. So those things work with native image, and some of them work especially good out of the box, such as reflection for some standard JDK classes. But overall, if you want to do reflection, serialization, etc., you need to give your specific consent and allow list for those things to work in native image. And this is kind of working by design in native image, but also it enables this interesting security angle where such attacks that maybe will be targeting those features are no longer possible in native image. And the same applies also to attacks that might be targeting the JIT compiler. So there is no longer JIT compilation in native image anymore. So those attacks are just not possible in native image. Okay, and I want to talk with you about what's coming up next for GraalVM and the things we've been on to recently. So one of the biggest news is this new GraalVM for JDK22 release that we just released 2 weeks ago. And I encourage you to go and read about it on Medium or check our YouTube channel. There are a lot of things in this release. We support Java 22 features. This is the fastest GraalVM yet, so as of this release. And also we made a bunch of improvements around developer experience as well. So I encourage you to go check it out. And I want to share with you also 2 ambitious projects that we are working on. So one project is called Layered Native Images, and that is supposed to solve a number of, let's say, challenges that you might be having with native image. So if you ever build a native image application yourself, especially if it's a larger application, so maybe something kind of enterprise grade, you might have noticed that build times take a while, and especially for large applications. And I think it's fair because native image does a lot of work at build time, and also it doesn't introduce any new work. It does the same work that your JVM would have done at runtime, only it pushes that work to the build time. Still, it's not always great, especially if you want to have that fast development kind of cycle, development loop. And for that, we're introducing these layered native images where as you are developing your application, you would only recompile your actual application layer. So basically the code that you wrote or you defined, and then you will be depending on some base layers that are already precompiled. And by recompiling on your own code, you will get much faster compilation times, and then you can build your application normally again when you're ready to deploy it. So this way, our plan is to have compilation times down to maybe 1 second or a couple of seconds. And another benefit that we can see there is that also resources sharing, and especially again in cloud deployments, where one application, let's say I have again my Spring Boot application, can have multiple instances and they all depend on same base layer. Maybe that's JDK, maybe that's Spring Boot. So they can all share those base layers and be more efficient this way. So this is an ambitious project, but we are actively working on it. Stay tuned for more updates. Okay, let me see how I'm doing on time. I think I need to speed up. Okay, and one more project equally ambitious is called GraalOS. So we want to introduce a new way to deploy applications, basically as native images rather than containers. And this way we want to simplify development and eliminate some of that container overhead, which is not that high, but we still think we can do better. So we are working actively on this new development platform that will be based fully on GraalVM native image. So also stay tuned, more announcements coming up soon. And I wanted to give you a few recommendations if I wanted to move my application to GraalVM and Spring Boot, what would I do and what would be my first steps there? First one is I would need to migrate to Spring Boot 3.x because as you remember, native image was introduced fully supported in 3.0. So migrate to a newer version. And then maybe if you're using an older version, but also if you're using a different framework or no framework at all, so you don't have any built-in support for GraalVM, add our native build tools. Now, for building your applications, I would suggest that you keep building them, testing, etc., basically developing on the JVM, especially if you are working with frameworks and libraries that work with native image. There are more and more of those every day, so you don't need to expect any, unexpected turn of events in that case. So just develop your application on the JVM and then compile to native as more or less the last step in your development cycle or closer to deployment. You don't need to recompile all the time. Only if you are introducing things that are major, maybe new dependencies, or if you are touching things sensitive to native image, such as reflection, etc. But normally you would just develop on the JVM and then compile to native image in your CI/CD or closer to deployment. There is also a quick build mode that will make your builds much faster, but this is only a development tool, so treat it carefully and only use it in development and then remove before deploying to production. And there are a few additional options that you can use to make your application faster. That is the profile guide optimizations that I mentioned. There is G1GC. There is a Mark native that will build an application tailored to that specific machine. And there is something called ML PGO. All those features you can try in that native Spring Boot repo that I have on GitHub. Okay, with that, I will wrap up. Here are also resources where you can get GraalVM, download it, get our latest guides, just try it out, read the docs. So if you want to screen share, but also I believe slides will be available. This hopefully will be the slide to use. And with that, that is it. It's also my Twitter handle. If you want to ask questions privately, you can totally do so. And thank you so much for having me.
Thanks, Alina. That was just great. So people are freaking out about those layered images and GraalOS. So when can we hear more about GraalOS?
Yes, I'm freaking out as well, or rather sharing an excitement. So for layered native images, there is a ticket in our GitHub roadmap. If you go and Google GraalVM roadmap or just Google GraalVM native images, you will find that immediately on GitHub. And then for GraalOS, we have an entire little website. So you can just, again, Google GraalOS and then find a website and you can track updates there as well. But I share your excitement. I think those will be very helpful things to have.
Yeah, I think I heard that at DevOps Belgium as well. There were like some funny statement about GraalVM replacing the JVM and then GraalOS replacing. What are you replacing here?
Okay, that's ambitious. Let's say not replacing, but giving a new, better platform to deploy applications.
Okay. Thanks, Alina. I mean, it's just great to have more options. I feel more options to just make us stronger so we can choose whatever works best for our application and for our use case and for our businesses, right?
Sure. Thank you so much for having me, Sandra.
Thanks, Alina. It was so great having you with us. And next up is Martin Lippert. Hey, Martin, how are the things?
Hey, Sandra. Great to be here. Thanks for inviting me and thanks for having me here. I'm really looking forward to this.
Yeah, we've already seen many things about Quarkus on VSCode. I can't wait to have more Spring on VSCode. So I believe that's what you're gonna do, right? I see here your T-shirt and the jacket. So
yeah, of course, all Spring. Yeah, yeah. Should I just dive in and talk about this stuff?
So yeah, pretty much.
Yeah?
So please
Cool.
don't miss what we need to install on our VSCode to do those things if it's on VSCode. I don't even know.
Oh yeah, of course it will be VSCode. What else, right? What else these days? Sure. Yeah,
thanks, Martin. The stage is yours. People, please remember, use the chat for questions. Give us thumbs up if you like it. And also just let us know how the tools are working for you. So Martin would love to know how the Spring tooling works for you, not just in VS Code, also for Eclipse and IntelliJ. Thanks.
Absolutely. Yeah, thanks for having me. My name is Martin. I work for the Spring core engineering team, so the team that works all on the Spring framework and Spring Boot. And my special area is the tools. So I work on all the IDE extensions, for example, for Visual Studio Code, also for Eclipse and for code spaces and stuff like that. So that is what I'm working on. So my goal really is to make you as a Spring app developer more productive every day. That's why I go to work and why I try really hard to make you more productive. So today, I would like to kind of cover a topic that probably is, I think, really important to many of us, if not all of us, when you implement Spring Boot applications, which is really about how to keep your projects up to date. Because if you look at the release schedule, and if you look at your inbox, and if you look at the news, there's basically a new Spring Boot release coming out quite frequently and quite often for good reasons, right? It's kind of fixing bugs, it's fixing CVEs, all those, and bringing new features, of course, in minor, major releases. But those updates, they come out quite frequently, and it's really good practice to keep up to date with them, especially with the patch releases, of course. They come out all the time, but also kind of relatively early jump to the next minor version, and probably also think about kind of jumping to the next major version if that is already around. So that's, of course, kind of good practice. The question is, what do you do if you face this challenge to update and upgrade your projects? So usually what you do is you take a look at the release notes, and if this is kind of a major upgrade, there's probably often be a migration guide or some really good material be prepared from the Spring Boot team to guide you through this migration. So you basically walk in, you read the release notes, you see what has changed, what do I need to do to my projects or to my project that I'm currently working on, and you walk through this whole list. And that can be quite comprehensive, right? Depending on the version change. Maybe in the patch version, there's not a lot to change, maybe nothing to change than just the parent POM version. For a minor upgrade, there's maybe a few things to change, little things here and there, but also a little bit more than just upgrading the parent POM version. And if you think about the migration from Spring Boot 2.7 to 3.0, there's actually a lot to do. Like it includes the jump to Java 17, it includes the jump to the new Jarkarta namespace and things like that. So that's quite a long list and quite some stuff you need to do to keep up to date all the time if you want to do that. And of course, you want to keep up to date all the time with the latest CVE patches and things like that. So you actually need to do a lot of that, and you need to do a lot of that manually. And that's where we thought, from kind of the tools perspective, we should do something about it. We should help you to deal with those situations more efficiently, more easily, and bring you into a situation where it's actually a pleasure and a lot easier to just jump to the latest version basically all the time. It's just daily business, right? So we split up this thoughts into two different sections. The first section is we would like to make you aware of new versions coming out directly in your IDE. So when you hack on your project, the IDE, of course, knows about what's the Spring Boot version that is being used in your project, because you have your project open, right? The IDE knows about that and analyzes the source code and does all the great Spring Tools features, but it also knows about the version. So it can basically tell you whether there's a new patch version, whether there's a new minor or even a new major version out there immediately once this new version is being published. So we would like to make you first, as a first step, aware of these new versions so that you never miss a new version again, and you don't need to watch other resources about that, right? You can just directly see this in your IDE when you open up the source code of your project, basically. And the second part is, of course, the next logical step is, oh, there's a new version, let me update to that. Help you with this update, help you with making those changes to the source code, and do as much as possible automatically for you. And this is not a silver bullet, right? It does not do everything, but we try to do as much as possible. There are limitations, so that we cannot really do everything inside the tooling, have this one-click experience, and then your project is being always upgraded to the latest major and it exactly runs as before, and we guarantee that. There are maybe difficult situations. There are parts that are not automated yet. There are maybe steps in the migration where you need to make a decision, where the tooling cannot really make a decision for you which way to go. There may be multiple ways in future versions about some certain bits and pieces of your code and things like that. We will, of course, improve this over time. We will help you with that. And we, of course, we need your feedback for that. So if you try those things and see what is possible and what is maybe not possible, where do you stumble upon situations that might be a good candidate for automating things in the future, please let us know. We really look forward to your feedback about those things. But that's kind of the overall framing here, right? We try to automate as much as possible, basically to help you with all the tedious stuff that takes a lot of time and really make this as effective as possible. Quick reminder, everything that I will show you, and I love to show you demos, that's why I will dive into demos right away. All the stuff's early days, right? So it's really early days. There's no guarantee that everything works out of the box for migrating every project in the world to the latest major version or stuff like that. But I would like to show you what is actually already working and where the tooling can already help you with, so that you can give it a try and you can see how far you can get with it. And with that, I would like to jump over to kind of a quick demo section for the session here. So what do I have? I have VSCode installed, and in my installation, I have, of course, the Java tooling installed, so the extension pack for Java installed, and there is the extension pack for Spring Boot installed. Those are the two major things that I have installed here, among a few minor things. But those tools bring you Java tooling, and they bring you kind of additional Spring tooling, especially all the stuff that I will show you. Basically, all those features are included in the Spring extension pack and the Spring tooling for VS Code. So it knows a lot about, now your VS Code knows a lot about Springy stuff. And the first thing that you might already see if you go to the problems view here in VS Code, where you see all your warnings and errors and information about your project from the Java compiler, of course, as an example. If you have the Spring tools installed, you also get additional information on your build file about the version that is available. For example, in this case, I have a pet clinic, of course, a pet clinic example. What else? And that is using 2.7.3, but it's still using 2.7.3. That's pretty old and pretty outdated. And you will get this information right away in the problems view. So you see, oh, there's a new patch version, a newer patch version available, 2.7.18 actually. And you could do something here about updating that. But as an additional information, you also get the information that the open source support for the minor version that you're on, 2.7, has already ended in November last year. So you can, of course, get commercial support if you want that. That kind of brings you commercial support for 2.7 until probably mid of 25, just as an additional information for you. And it also tells you that there's a new major version around. So there's already Spring Boot 3.2.4 as the latest major version that is there. And you can see all this directly in your problems view all the time, basically. When I say all the time, this might be a bit concerning maybe here and there, because sometimes oh, you work on, let's say, a 2.7 project, and that is just fine because you are on a commercial support plan. You don't need to know about these open source support ended, or you don't need to be made aware of there's a new major version. You know that, right? You don't want to see all this all the time, or you would like to kind of customize this to your situation. So you can do that. In the settings, basically, for the Spring Boot tools, there is a section about versions and support ranges where you can actually set all the levels for all these different validations that we do for you. So you can say, okay, I would like to know about the latest major version as an information, as it shows up here, right? Or please ignore this. Please give me this as a warning or even as an error. Or you would like to say, oh, if there's kind of a new patch version, that should really be an error. That should jump right into my eye as a big red warning. You can switch this over. If you are not interested in the open source supported support ranges, you can actually switch this off. Or you can switch over, say, oh, I'm on a commercial plan. I would like to know about the commercial support range, and I would like to get notified if the commercial support is running out or has ended for this version that I'm using here. You can basically configure that yourself. So tailor that to your situation, to your context, what you would like to see. But using these settings, you are actually able to get exactly those warnings and informations in the problems view for your project, for the Spring Boot version that you use right away compared to what is available publicly or commercially. And this not only works for just one project. If you have multiple projects in the workspace, you can of course see this for multiple projects as well. The next logical step is, of course, oh yeah, thank you for making me aware if there's a new version. What's the next step? Of course, I would like to update to that. So we give you quick fixes for that. What else, right? So you can click on these light bulb and you can see, oh, please update my project to 2.7.18, basically, but just switching over my parent POM version in this case, because it's just a patch version. So that's an easy thing, straightforward. You can also kind of open the release notes quickly to take a look at what has changed, things like that. But you can also do like, oh, please upgrade me to the latest major version from this version that I'm on. So please directly upgrade this project to Spring Boot 3.2 in this case. And I can actually do that. I see this, of course, also on the other information about the new major version. Say, okay, please upgrade to that version. And I can actually give it a try. So let's give it a try. So in the background, you will see kind of a quick information here, what's going on. And then once the tooling has computed all the necessary changes and analyzed all your projects, it gives you basically the option to, yeah, make those changes. I don't care, because I have my git commits or whatever, so I can take a look at the changes in a different way, or I can do a quick preview. So give me this preview. And in this preview, it actually tells me all those changes individually. So let me check the POM file, for example. I can see in the POM file, it is not only change or update the version of the parent POM, it also updates the version of Java to 17. It updates the version of a specific extension here. It adds additional dependencies that are maybe needed. It, for example, updates the coordinates of the MySQL connector because those old coordinates are no longer valid in newer Spring Boot versions. They have changed. So it updates stuff to that, and so on. Really, really nice. So it not just updates the version, it also updates all the other stuff. But this is not all. It does a lot more. For example, let me take a look at kind of the next thing here. It, of course, updates your package imports to Jarkarta, at least for those packages that have moved over to the Jarkarta namespace. So it does that for me for basically all the classes in my project, which I think is really cool. And we can walk through basically all those changes here and see what exactly is going on. So there are more Jarkarta packages being changed, more Jarkarta packages being updated. And oh, here, there's also kind of a little bit of cleanup happening behind the scenes. So it basically removes this name parameter for the path variable because it knows that, oh, kind of it's not needed, right? You don't need this in this case, or you don't need the owner ID here in this case. So it removes that for you. Does a little bit of kind of cleanup, a little bit of polishing along the way as well. As another example, let me take a look at this thing, for example. It also updates the Jarkarta things, and it does some polishing. If it finds, for example, something like, oh, there's an auto-white annotation that is not really necessary anymore, it not only removes the auto-white annotation, it, of course, also removes the import statement. So it really cleans up the stuff in a meaningful and nice way for you, and updates everything to the Spring Boot 3.2 version. Let me quickly take a look at the crash controller and what changed in there. So it even updates stuff to the new Java text block feature, if it finds that kind of is a reasonable step to take here to modernize your code. And you can then just say, oh yeah, please apply all those changes to my project, and that would apply all your changes basically to your project. So let me discard that for the second. So this gives you an idea about what is the tooling already all doing for you, basically updating all your source code and polishing your source code. Sometimes, and I'm one of those persons as well, I don't really like the tooling to do all the polishing as well. I would really like to kind of focus on just do the upgrade part, and don't, for example, use text blocks because I would like to do that myself in a separate step. I would like to not do that at all for whatever reason. So in the tooling, we actually give you the option to customize that and to take a look at what's going on behind the scenes. And for that, there's a command that you can execute to upgrade your Spring Boot project instead of executing the quick fix. And in this command, we tell you what are all basically the ways to upgrade. So there's a way to upgrade to 2.7 that doesn't really apply here, but there's a way to upgrade to 3.2. And I can actually say, yeah, let's do this, but let me take a look at what's going on behind the scenes. So this consists out of individual steps that are all being executed when I update this. For example, change the version of the parent POM, migrate to Spring Security 6.2, and so on and so on. Enable virtual threads on Java 21, and more. And I can basically dive in here. So for example, I can say, oh, migrate to Spring Boot 3.1, migrate to Spring Boot 3.0. That's kind of basically it migrates to all the different versions. Oh, migrate to Java 17. Oh, use text blocks. I don't like that change, so unselect it and basically execute it without changing everything to text box. So that's actually already being possible. So you can do this. And we will work a little bit on this to kind of make it easier to select these kind of, do only the upgrade and do the polish things as a separate step. And part of that is already possible. And this gives you an overview about what the tooling is already doing. Behind the scenes, actually, when I go back to my slides, we use an open source project called Open Rewrite for this. So Open Rewrite is basically an open source framework that allows you to do these code changes, basically these refactorings on the source code level in a very automatic way by describing those changes either in YAML or implementing those changes. And then you can combine those changes to larger transformations. This, I think, is really, really interesting. So we did not really reinvent everything on our own. We use and reuse this open source project to do this. For example, you can use Open Rewrite, of course, without the tooling as well. So you can execute Open Rewrite and make those changes yourself manually by executing a Maven artifact and the Maven goal on the command line to make those changes to a project. For example, to migrate from a Java version to another Java version, patching CVEs, what we have seen, migrate between framework versions. And the interesting cool thing is that it does not only change certain things, you can really do a lot, right? You can say, okay, in the migration between framework versions, I would like to upgrade Java stuff. I would like to upgrade dependencies in my POM file. I would like to change keys in property files. I would like to make changes to my source code. If I, for example, have a deprecated API that got removed and I would like to switch the call side to a new API, I can do that. I can modify the source code of my project to make a different call if I can automate this change somehow and implement that as part of Open Rewrite and then execute that as part of the tooling, which gives you basically this little UI around that to automate and execute those changes. And that's what we do in the tooling, right? We basically give you a list of all these Open Rewrite recipes that the community worked on. And then we execute them inside of the IDE and give you a little bit of UI interface on top of that, for example, to select the exact recipes or to change the structure. But if you want to, you can, of course, also execute that on the command line if you're eager to do that in that way or in a different IDE or different environment. And while we were doing this, we actually figured out that, oh, this is cool. We can automate code changes. And for example, you have seen this code change to remove an unnecessary auto-wired annotation. Or there's a recipe implemented to convert an auto-wired field from field injection to constructor injection. So it creates a constructor, removes the auto-wired from the field, makes the field private, final, and so on. And if there's an existing constructor, it adds that as a parameter to the existing constructor, things like that. And we thought, oh, this is very similar to stuff that you do in your project as well, while working on source code in the IDE, right? You have these little warnings, these little informations, these little quick fixes. So we basically took this and went the extra step to do something like reuse this for and while working on your source code directly in the IDE. So what we do is we have specific validations that are very Spring specific. So they give you validations about there's an auto-wired annotation, for example, that is not needed on the constructor. So you could remove this if you want to. This is not necessary, right? It gives you this little validation. And we implemented that because it's deeply integrated in the super fast validation engine on source code. But the next step is actually to modify the source code, right? If you execute a quick fix like this, please remove this. We need to modify the source code. Maybe we need to remove the import statement. Maybe we need to do more sophisticated changes than just removing this one line. This is just an example for this. So what the tooling is actually doing behind the scenes is it does this validation thing, and then when you execute the quick fix, it again executes this little recipe behind the scenes to make the change to the source code, which I think is really nice and really cool, because now we can really reuse all the existing open rewrite recipes to make those changes. For example, convert an auto-white field into something that is a constructor injection instead, which I think is really, really nice. And with that, my little demo, my little quick walkthrough is basically already done. So if you would like to know more about the Open Rewrite project, here are some links for that. You can go to the GitHub page. Here there's docs.openrewrite.org, where you find more information about how do I write my own recipes, because you can do that as well, of course, for your own in-house company libraries, for example, your own code changes, your own publishing things that you would like to apply maybe across projects in your company. And there are links, of course, for the IDE integration as part of the Spring Tools. And if you try this, if you have feedback, if you find missing pieces, if you would like to get things improved, if you have additional ideas, please go to the GitHub Spring Projects /STS4 repo and file issues and give us feedback. We love to hear about that. And also of course, go to the chat. And my colleagues are also around to answer questions, which is awesome. So with that, also feel free to contact us on Twitter. I would like to thank you for joining the session and for watching it. I hope you get some ideas about how we try to help you upgrade to the latest Spring Boot version. And with that, I turn it back to Sandra to kind of wrap it up, I guess, or open it up for questions.
Hey, Martin. Thank you so much. So I guess we don't have questions from the chat, but everyone is just sewn off with Spring tooling. And there's even one guy, I'm sorry, I guess I can't say the name correctly, but it's something like Ikbanam. He shared the story that he moved up from Rails towards Java just because of Spring. So he only moved towards Java for Spring Boot. So I guess, and that's also thanks to the great Spring tooling integration in the various ADEs. So thanks again for wrapping it up and also showing us how to migrate to newer Java versions. You know, earlier I had a session about load testing, and we just managed to speed up everything by like 90% just by switching from Java 8 to 17. So that's easy. And you shouldn't lose that possibility. And yeah, with Open Rewrite and the steps you have to accomplish just to migrate, it's not that hard, right?
Yeah, I hope so.
Yes. So thanks again for being with us. That was, I feel we had the best sessions in the European EMEA stream. So thank you for being part of this as our last presenter. So I guess it's time to wrap it up. Remember, we do have the survey. So it's here in place. Please tell us what you think. Tell us what you feel. Give us a thumb up on the YouTube channel, on the stream. Please do the survey. Make sure you are logged in with your Microsoft account so you can also redeem your rewards. So we have this Microsoft rewards points where you can then buy something nice out of it. You can have like a Starbucks coffee or Amazon gift card, you name it. There are a lot of options. And yeah, it was just so great being here with you all. So we learned, first of all, everything about LangChain4j. Thanks again, Lize, for being with us here. We had the Red Hat team enlightening us about Java on VSCode. And then there was Oleg from Testcontainers who told us like how to use it, what's up with the Docker acquisition. So it just makes perfect sense to me now. And then we had Rory who presented on Semantic Kernel, the release candidate 1. So AI for Java is there. We have Spring AI. We've seen it in the American stream. We have LangChain4j and Semantic Kernel, what we had here today. So thanks, Rory, for sharing that with us. And then we had Reza, who told us everything new about Jarkarta EE 11. So thanks again for enlightening us about this topic. And then we had Alina from the GraalVM team, who just made us a little bit cautious or very excited even for GraalOS and also those cached layers. So let's see what we will get there. I fear there is more to expect very soon. And last but not least, we had Martin here from Hamburg, who told us everything about Spring tooling and how to migrate your Spring apps within VSCode, making use of Open Rewrite. We have 3 minutes left. So again, we have the on-demand sessions. You can find them at jdconf.com and on our Java for Microsoft for Java Developers YouTube channel. So please feel free to search for them. You can also stream back or go back in the stream, rewatch the session if you have missed anything. Yeah. And with the on-demand sessions, as you can see here, we have more about Spring tooling. We have more about Jarkarta EE or also Web UI with Java. I mean, that's coming up again. Also, what is Jarkarta concurrency, or how you can make use of the Maven timeline plugin. So I already have a lot of sessions in my backpack I can watch later on. And with that, just a reminder, take the survey, use the chat for more questions. It had been a pleasure to being with you here. It was just so great. My name is Sandra Ahlgrimm. You can find and follow me on Twitter or connect with me on LinkedIn at Sandra Ahlgrimm. Happy to be with you. Bye-bye.